President of PHTA of San Diego. If you guys might know Javier Payan, who is also PHTA here in San Diego. So our whole goal at PHTA is just to create we have a lot of goals, but one of our biggest things we feel strongest about is education. So we want to have opportunities that are easy for pool guys to get. That we know you guys are all busy. It's almost summer. For you to take an entire day or 2 days in a row, it's impossible. It's extremely hard. So we want quick, kind of informal, fun training opportunities, and this one's we've done a lot in the past. So please follow our Instagram because we try to promote that. We haven't done too many this year, but I'm really excited about this one today because it's for a product that I personally really believe in. My team at Precision Aquatics, it's one of our favorite products. So Chuck and Ted from IPS have come down to present to you guys some chemical automation stuff. I know that this presentation isn't necessarily sales based. You're going to go through a lot of technical stuff and maintenance, but I just kind of want to give you guys a minute for what I truly believe in this product. We install it in all of our commercial properties, and it does not have to just be commercial. This can also be in residential. How are we providing safe, quality swimming experiences for our customers in a 1 day a week or even a 3 day a week service schedule? It's impossible. The best pool guy in this room with the most chemistry knowledge and experience cannot do it, I promise you. And it does not matter what you've done and all the tips and tricks. I don't care how many tablets you stuff under the skimmer baskets, it's not working. Invest in IPS or any chemical controller. You're going to learn about chemical controllers, period, in here today, but I really believe IPS is the way to go. It is not an expensive investment or anything major. And the fact is, you guys, if you can take apart heaters and fix pumps and shaft seals, this isn't hard to learn. So by you guys investing a little bit of your time today, it means a lot to all of us, and I think for the industry as a whole, because if all of us in this room, this is a killer crew right here. If everybody in this room is familiar with chemical automation, the industry, when you leave today, the industry takes a little bit of a step forward. So Chuck and Ted from IPS Controls, local company too, Temecula. I mean, when you guys call, he answers the phone. It's not a call center, he answers the phone, or Dan does, and they have all of the information right there. They'll walk you through it. So if you haven't sold and installed an IPS controller, please get some pricing. Especially want to say thanks to the Pool Corp, everybody from Pool Corp. Tara, also PhD, I don't know if she's in the room, but she's the vice president of the chapter this year. We love Tara. She runs the Escondido branch of SCP, and Philip from this branch here. So if you're new to Pool Corp, thanks for coming. But this is a great San Diego branch. They got a lot of this stuff in stock, and they can help you with pricing. One last person, I hope we don't forget anybody, but if you guys know Russell Kennedy from DCA, Russell helped a lot with putting this together too. He's going to be the local sales contact for IPS as well as other products. He can walk you through all those, but Russell's also a OG San Diego guy. If you guys don't know him, make sure you introduce yourself, and he can always help you with this stuff. So PHTA of San Diego, please follow our Instagram because that's where we put all of our stuff. It's not just education, it's all of our networking events and stuff like that. We'd love to see you guys out there. So thanks a lot, guys. Appreciate it.
Let me just say real quick, thanks Dustin, appreciate your support. So if you call the 800 number on there, you're going to get myself or Dan, and we can answer most of the questions that you might have. Certainly any the technical side, the sales side, we can answer all those for you. We kind of have a lot of SKUs that look similar if you look at the back of the sheet there, or the back of the brochure. So we can help you kind of navigate. I always recommend if you're not sure, call us and we'll clear it up for you right on the spot. You don't have to go through a phone tree. We answer the phones. So if you have questions about, especially about chemistry, commercial stuff, the spa chemistry on commercial, all that crazy stuff, Ted's the right guy to call. You can call us too, but Ted, he gave you his cards. He's got his cell number on there. Reach out to Ted, use him, abuse him, whatever you need to get. He'll help you with the questions that come up. Got years and years of experience running 150 plus bodies of water in Palm Springs, Palm Desert, Coachella Valley area. There's not a worse environment in the country to run commercial service out of, and he has all kinds of experience doing that there. So anyway, that's my part of it. Ted, there you go. I primed the room. You can tell they're excited.
So you guys, just like Chuck was saying, I used to own a commercial pool company. I sold it this end of May will be 3 years that I sold the company. But I did everything you did for the last 22 years. Okay. Besides that, I worked for another company before that, so I've got 25 plus years of experience. Commercials where it's at, you guys, it's where the money's to be made. It's fun. The units will do everything you ask it to do if you set them up correctly. So that's what this whole class is going to be about. Preventive maintenance. Basically the outline that we're doing that you see, these are a lot of the questions that people will call us with, or we find out when they call in and we start talking with them. We ask them these basic questions, especially myself, being in the commercial pool business. These are the things that I found that were very useful, okay? Example, the very first part, pool circulation. Now, you're probably looking at that going, well, what does that have to do with the controller? It's huge, okay? If a pool is a kidney-shaped pool, or you have a rectangular pool, and you have eyeballs that are in the pools, I go out on jobs with you guys, not you in particular, but all across the country, and I'll see the eyeball pointed to the surface of the pool, okay? Water's boiling at the surface. Why do you have that? People will say to me, oh, well, because the customer likes to see the water moving. Well, who's paying for the chemicals? Who's maintaining this? You are, right? So what we want to do in our pools is you want to have all your eyeballs pointed either at 3 o'clock or 9 o'clock so that you get a circular motion in the pool. You don't want to point them across the pool. You want them to be on an angle like a 45, but you also want them on a 45 to the bottom of the pool, okay? We all test, and the health department comes out and tests. Why do they test 18 inches down? Because chlorine turns to a gas. It's going to gas off. We don't want to be testing at the surface, nor do we want our water boiling at the surface. We want our eyeballs to be pushing the chlorine to the bottom of the pool, and we want it to be in a circular motion that we move the pool. Now, if you get into a free-form pool, where you got bottom returns, okay, they're really a pain, okay? They look beautiful, but those are our pain in the butt pools, because you'll get pooling in those little pockets in the pool, right? Where you have no circulation pushing things. If it's got a bottom return, it takes that much longer for that chlorine to saturate the pool and get to the return or back to your main drain. When we do our eyeballs, the idea is moving it towards the main drain, right? We want our main drain to be the biggest player in the thing, in the pool, versus your skimmer. We all think that, we need to have 50-50 in these pools, all right? You don't want to do that. If you've got a split where you have a main drain and you've got a skimmer, you want your main drain to do the most work. You want things to be pulled through your main drain. Your skimmer, as long as your skimmer is working, that's the secret, is to shut down that skimmer to the point where you can stick something in there and feel that it's moving some water, but use your diverter correctly also. Okay, so the diverters, I want to talk about that for a second. Your diverters, if you got a pool, let's just say this is example of the pool. This is the pool. You got a main drain down here, and you got a skimmer down here, and you got skimmers on both sides of the pool. Pool equipment room's here. Water takes its least path of resistance. So what's going to happen is the skimmer that's closest to the pump room is going to be doing the most work. On your diverters that are in the bottoms of the skimmers, close it down to where it just has a very small crack on the ones closest to your pool, your pump room. The one furthest away, open it up a little bit more. All you're trying to do is create a venturi in that thing to be able to pull in some leaves and some bugs and things like that, okay? Your main drain is what we're going to do most of your work, and you're going to want to have your main drain, because your main drain's coming back to and giving you exactly what your chlorine reading is in the bottom of your pool. Your skimmers is going to give you some readings also. So when you take your test here at the front port, this is where you want to take your test, you guys. This right here is going to give you a mixture of that main drain and the skimmer, okay? Circulation, like I said, with the eyeballs, valving things so that the valve is going to be adjusted. This is where it's nice to have a partner when you go out and do it, is that you pull those pucks out of the bottom of the skimmers, you get somebody in the pump room. In the pump room, someone starts to turn that valve down for the skimmer. Stick your hand in there or put some dye, drop some pH indicator in there and see that it's actually pulling, you're good. If the guy turns it too far, you'll see that it just sits in there and doesn't do anything. Well, then you got to back it off a little bit. But run your main drain at 100%, okay? The diverters and weirs, you guys, are super important in your pool. I know they're a pain with the weirs because people, for some reason, kids like to play with them, and people pull them out all the time. and we fight with that. But it's something that's essential in the process for that skimmer, okay? We want to get that garbage off the top of the pool. We want to get it inside the skimmer so that it's not floating on top of our pool and we can actually get it to collect into the basket, okay? You guys have any questions on that part?
When you say eyeballs, you're talking about the returns?
Returns,
If they're the
right, so a lot of times some builders will just cut them off at the wall and you got a
Yeah.
pipe sticking straight out. Right here at SCP, you can buy a kit, a retro kit that will go right in any of those and give you a directional eyeball.
Okay.
I hate those pools that don't have the eyeballs on because
Yeah.
it's just pushing the water straight out like we talked about. It's not helping you to push it to the bottom. The idea is to get it to the bottom of the pool because we don't have little scrubbing bubbles that are in there going around cleaning for us. And so if you put the chlorine to the bottom of the pool, you're gonna get better saturation in your pool. Plus it's gonna get you towards your main drain, okay? Controller setup. Anybody else have any questions about the skimmers, main drains, any of that stuff? I'm gonna back up just a second on that, just to tell you why that's so important. I had a guy in Texas just recently came into our booth at one of the shows, and he had a big rectangular pool. And he said, look, I'm ready to walk from this pool. I've had it for 2 years. I can never keep it balanced. I have spotting. One corner's 3 parts per million, the other corner's a part per million. And it's like, it's just been a headache. And I said, well, what are you doing with your eyeballs? And talked to him, and he goes, well, they're just pointed to the surface. So I said, well, do me a favor. I'm gonna be here for a few more days. Go to the pool, do what I'm telling you to do, and tell me what your readings are. He went out, fixed the eyeballs, adjusted the main drain skimmer, comes back and he goes, oh my God, it's like a miracle. Like it just made the biggest difference. That's that little thing that made the difference. Because what happens is if your eyeballs are pointing out, those corners of the pool, there's nothing moving it out until a swimmer gets in there, okay? So that's why that's really important. Controller setup, I'm gonna skip that for a second and go down to correct pump sizing, then we'll go back to controller setup. This is really, really important, you guys. Just randomly, are you putting in controllers right now?
No, not at the moment.
Anybody, who's doing controllers? Okay, so if you guys are doing controllers, what pump sizes are you using?
Depends on our pool. I mean, we see a lot of IntelliFlow 3s, like you're gonna see that on more
You're
pools.
talking about chemical pumps.
Chemical pumps,
Oh.
for the controllers.
Okay, so we do, for our pool chlorine feed, we're always at 38 gallon per day millichems. We do standard and millichems, so either the 50 standard or the 38 on the pool chlorine, but we usually will standard put in 12 GPD acid feed. And then we go down on spas, we change that up. If it's a ever changing, because you know, this is a big deal.
Okay, so I'm gonna give you a 100% different mindset.
I'm
Okay, and that's good that you're here and this is what we're doing. You guys, the secret of controllers is you want to get product into the body of water fast, okay? And making your correction in pH needs to be as fast as possible. pH is really the leader in the swimming pool, you guys. If you keep pH stable, the effective kill power of chlorine is increased, right? So as pH climbs, effective kill power of chlorine is reduced. However, at the same time, as pH goes up, your ORP number that you have here, you might be saying, I'm just gonna throw an example out there, say 700 was reading on there an ORP. That might have been for 3 parts per million. But as my pH goes up, this goes down. They work in conjunction, okay? So pH goes up, ORP comes down. Well, it went down to 695. On comes your 38 gallon a day pump, starts pumping chemical. Well, it's gonna stay there and it's gonna go through a feed cycle. It's gonna wait 5 minutes or whatever we designate as our delay time, and it's gonna feed a second time. Now we're pumping chlorine in there uselessly because we didn't need it. What we needed to do was get our pH down fast so that we balance our ORP, okay? If you get your pH down quick, you'll see that you're balancing your ORP and you're gonna stay in a window much tighter. So back again, the secret is just getting it in quick, right? So, that being said, I standardize everything that I do. I'm a big proponent of big pumps, okay? Like the 85 gallon a day Stenner. If you go with Rollichem, it's a 78. It's gonna be the Stenner's gonna be 85. Here's why. I get back again to what I'm saying to you is on the acid, all right? Getting it in and getting it in fast. We're diluting our acid, you guys. We're not putting in straight acid. You don't need to use straight acid in this, because when you're doing a controller, it's like an IV drip. As water's passing through the pipe, we're injecting into that pipe. So every 5 feet that moves, about every second, 5 feet, we're injecting some chemical into that as it's going, as the pump is going. The faster we can get it in there, and the faster we get it out to where those eyeballs are, the more we're saturating the pool, the quicker it gets back to the return and comes back and tells us that our pH is good. That means our ORP starts to get stabilized faster. The problem with a 12-gallon-a-day pump is that it's so slow that what happens is it's going round and round and round, and it takes forever for it to finally get into the return, get there, and the next time it's already feeding another dose of chlorine. So we waste chlorine, okay? So how do we figure that out? How do we figure out how fast our return is? Everybody carries sodium bicarbonate, everybody carries soda ash most of the time, all right? Go out to the pool. If this is the shape of the pool, main drain's down here, middle of the pool. Get your pH where you know you're pretty close, 7.4, 7.5 on the controller. Take your soda ash and give it a little splash into the pool, okay? Look at the time. Mark the time that you put that in there. Run into the pump room and see how long it's going to take for that soda ash to get to the main drain or to your skimmers and come back and start seeing fluctuation on your pH. That's going to give you an idea of what your return is, how fast that is. If it's a really fast moving pool, it could be 3-4 minutes. Then a 5-minute delay is good.
You suggest using like a powdered substance, like a soda ash or a bicarbonate,
Yeah.
not a liquid?
No liquid, just go with
Powder.
Yep, just go with powder.
Okay.
And just broadcast it like you're feeding fish, right out in the middle of the pool, so it has time to be able to come back and pull itself towards the main drains through skimmers, things like that. When you see that start to fluctuate on the pH, and say that was 7 minutes, well, 7 minutes is gonna be your sweet spot, okay? We send the controller out, and it's gonna have a 5-minute delay in it. Most people say, oh, well, 5 minutes, because I ask that all the time. I go, why do you have 5 minutes? Well, because that's what it takes. Well, sometimes it's not, because a spa returns really, really fast, right? So you can say, well, 5 minutes is plenty, as long as I'm getting it in there and getting the pH down fast. That's what we're trying to accomplish. So once you've established how long the delay is in the pool, if it's got good circulation, it's got good filtration, you're gonna see it return pretty quick, okay? That's where you're gonna go into the controller where it says delay time and mark that as your 7 minutes, all right?
So
Put that
that's
in
the
7
test, that you use that test to kind of.
Gives
get your
me my
baseline
good
for your
idea to
delay
start.
time
That's my
specific.
starting point where I know that's what I need to have, right? You're always gonna wanna feed your acid, and then you're gonna wanna feed your chlorine. I always set mine up where I have a little bit more runtime on my acid than I do my chlorine, okay? Because once again, I wanna get it down fast, right? So if I have a 1-minute runtime for acid, I'm gonna have a 45-second feed time for chlorine. If I have a 2-minute, I might have a minute, you know, on the other. If you see it not keeping up, well then you add runtime, or you go start working on that delay to make sure that you're falling where you're at, okay?
To be clear on that though, this is based on having large pumps, because I'll tell you, like, you've got 2 big commercial builders in town. Both of them install your controller, so you guys are gonna see these in pump rooms that you didn't install them. They'll put in 10 GPD pumps. They don't believe what you're saying. It's not they don't believe it, it wasn't designed that way. So just don't think the controller's not working if you're giving it a 10-second feed time on a 10 GPD.
And I know the builders that you're talking about.
Yeah.
and-
That's correct.
And they're using Stenner pumps. And just so you know, the greatest thing about a Stenner pump is you can turn that pump in from a 10-gallon-a-day pump to a 50-gallon-a-day pump by changing the tube. So if you've got, he's talking about a high-pressure pump, so the 2 builders we're talking about use high-pressure pumps on everything, even if they don't need to. So they could have a grade level equipment set, and they're putting in, because they standardized on these. So they're putting in a high-pressure Stenner pump, 10-gallon or 22-gallon, I think are the 2. So you can take and put a number 5 squeeze tube in that Stenner high-pressure pump, and now it's just like a 45 M5. It's just a 50-gallon a day pump.
Will that
So-
really change? Because you go from a number 2 squeeze tube that's like a pencil, right?
Yeah.
You change it to
Very,
the,
very
we
much.
call
Yeah,
it pencil or
it's like a
Sharpie.
pencil because it's thick to handle 100 PSI.
Yes, but when you go bigger though, that will actually modify its GPD.
Yeah, they use the same motor, it's the same motor, it's just different tubes.
Yeah. And we're gonna talk about the tubing, and we're gonna get to that.
Yeah, so it's, yeah, that's,
With the hose.
so that's a really cool thing about Stenners, yeah.
No, all you're doing is changing the tubing.
Yeah, Rollicams on the other hand have a different motor in each model. The motor turns, they use the same squeeze tube with a different motor. So the 12 turns really slowly, the 77 turns really fast. So so you don't have that option on a Rollicam. You do on a Stenner. Yeah.
So that's, and that's one thing that I'm gonna talk about too, is standardizing. So if you're using a Rollicam, get rid of the clear tube that it comes with, okay? Don't use it. That's fine for indoors, but it's gonna last a very short period of time, okay? Go to the black rubber tube that they have. It'll last longer.
This is the squeeze tube he's talking about.
The squeeze tube, okay? On the Stenner, number 5 squeeze tube on everything, okay?
So you're
Standardized.
saying, so you're saying use that flat, not just on acid then, use it
Both.
on
Both acid and chlorine.
Okay.
Yeah. The number 5 squeeze tube, if you're using Stenners, you guys, I'm gonna talk about output on these pumps. This will give you what the output is, and you'll understand more of why you're using that number 5. But back again to using the same things in everything you do. Use the same size tubing that you're pumping your chemical in, instead of 1/4 inch and 3/8. Standardize going 3/8. Standardize the type of injectors you use, okay? Standardize the squeeze tubes, all that different stuff. You go on vacation, he covers your property, he drives all the way across town and finds out that you have a Rollicam on there and he's got his Stenner squeeze tubes. So if you're using all the same product all the time, we can all work together to help each other out. He might be closer in an emergency call. He can go over there and change out a tube for you if there's a problem. When you don't have the exact same things on your truck, it makes it difficult. And I can tell you in my standpoint, I had 27 guys working for me, and when I standardized everything, man, my emergency phone calls went to 0 because everybody could cover it. Okay? So it's really important. Back to understanding the pump, okay? With a number 5 squeeze tube, if you're using an M45, okay, that pump has a capability of 4.5 ounces of output for every minute of runtime. If you go to the 85 pump, that has between 7.2 and 7.5 ounces per minute of runtime. So if I put in an M45 and that after 2 months my squeeze tube starts to get worn, I'm checking my output. I might only be putting in 2.5 ounces. But my runtime on my controller was 2 minutes. So you can see now I'm not keeping up. You're wondering why you're not keeping up. So it's either you gotta do one of 2 things. You gotta make an adjustment on your controller. But if you're gonna make an adjustment on your controller, you better start logging things, because you're not gonna remember when you put a brand new squeeze tube in that you put it at 2-minute feed time instead of a minute, and you're gonna overfeed, all right? So go to your number 5 squeeze tube, you're 4.5 ounces. On the 85, you got 7.4 to 7.5, somewhere around there in ounces, depending on the squeeze tube. The number 5 squeeze tube, when it gets half worn out, you're still putting out almost more than you would have if you had the M45, okay? So I love the larger pump for that reason, and for the reason being that in our controller, when you go to, let's go down to dose time, you can see how you can take that dose time and you can take it way down here. So when someone says to me, oh, well, I'm afraid of putting a big pump on there because it's pumping out so much chemical that I'm gonna overshoot. Well, you won't overshoot if you understand how many ounces you're putting into the body of water, and we're gonna talk about that as far as how you know how many ounces to put in, okay?
Quick question, so you're talking Stenner, right?
Stenner in particular.
So are you more of a fan of the Stenner versus the Rollicam then? Or?
No, not at all. Actually, I mean, the Rollicam's a great pump. So you would do the exact same thing with the Rollicam. You'd go to the larger Rollicam.
Okay.
When the squeeze tube gets half worn out, you're still pumping out more than you would have if you went with a 38-gallon a day.
I know the one thing that we have to do is we have to get Corp to start inventorying the higher volume ones.
Yeah, if you
because
walk in and say,
they
give me a
keep the
Rollicam pump, it's gonna be a 12.
Yeah, they keep the
Yeah.
12, and I think we've been taking, what's the next one up, 25 or?
38.
38.
30, yeah.
12,
So I guess
38,
we've been putting the
77.
38
Yeah.
then in, but
The
a
12
lot of times we'll have to order
Yeah.
them because they stock the 12s, but not the.
Here's the problem with the 12-gallon a day. It's very, very slow in putting things in, you guys. The 12-gallon a day was years past, okay? You saw that little timer that's on the front of the roller cam and all that. That was for guys years ago that we would have an outlet on the wall, we'd plug it in, we didn't have a controller whatsoever, and they would put it on, you know, put it on 5 and they'd let it run, and then it would shut off and let it run, it would shut off. And so they wouldn't overdose or would, you know, it was slow putting the product in. Today with the chemical controller, forget about any of the dials on those controllers, set them at wide open and use your controller with the time feed, because this is gonna be controlled right here. It's gonna feed 10 seconds or 8 seconds, but we're gonna dose that based on how many ounces the output is. For example, it takes 1 ounce of liquid chlorine for every 1,000 gallons you have to get a part per million. So if you've got a 30,000 gallon pool, you put 30 ounces in there, okay? So basically a quart, you're gonna get 1 part per million. So it's really nice with controllers, because if I know that my pump is capable of 7 ounces to 7.5 ounces of feed for every minute of runtime, okay? My pool's 30,000 gallons, okay? How many ounces are you putting in, or how many minutes are you doing? If you're running a 4 minute, you're gonna get a whole part per million. Well, you don't need a whole part per million instantly in these swimming pools, you guys. It will recover pretty fast with 2-3 feeds, right? Unless the bather load is incredibly heavy. I had a property that was, you walk across heads, there was so many people in the pool. In that situation, you're gonna run longer feed times because you need a quick recovery. But I'm gonna show you another little tool in here that'll help you out too in those heavy bather load times.
Hey Ted, before you leave the 85s, I was just curious, have you ever had challenges with the amperage requirement on that pump versus the relay that's inside?
No.
I mean, you guys have pretty bulletproof relays, but
Yeah, no.
we really don't get into those big pumps. Is there
Yeah,
any
the
risk
relay's
there?
not a problem. Relays are 20 amp relays. They'll handle.
You're not-
That's why we never replace the relays, because they're oversized. We're fused at 5 amps, so our fusing is 5 amps. But you're with a Stenner, even a 110 Stenner, you're still way under that. You're probably right around 2 on an 85. You're under that a little bit on a 45. So yeah, no issues.
So let's back up to that 30,000 gallon pool. So if I had a 4 minute feed time feeding 28 ounces of chlorine into that pool, right? It would be back a part per million instantly. Now, if I cut that in half and say a 2 minute feed time, I'll go through 2 feed cycles, right? So if I have a 6 minute delay, I'm gonna feed 2 minutes, it's gonna go off for 6, that's an 8 minute cycle. So within 16 minutes, I'm feeding enough chlorine into that pool to get it back that whole part per million. Now, I have a 12 gallon a day pump on here, all right? 12 gallon a day pump is gonna give you like 1.2 ounces, and you got a 30,000 gallon pool. You're fighting the tail of the cat constantly.
Running all day long.
It's running all day long, okay? And what do they say the secret is getting your pH down fast, right? So it's not, don't look at the pump size and be afraid. That's what I'm trying to stress with you guys, is we see this all the time. Chuck can tell you, if I've talked to Rollicam a million times, I wish they would take that 12 gallon a day pump and put a grenade in it and just get rid of it. It's not necessary when you're doing automation, okay? But they still have people plugging things into the wall. So that's why they keep it. The Stenner pump, the Rollicam, either of the bigger pumps, I mean, if you just are afraid and you wanna go to the 45s, it's gonna have 4.5 ounces of feed time. It's just that every time that you get into the controller, you gotta look at how many cycles it's gonna get within an hour. So if you put in a 4.5 ounce pump, and it takes, you're pumping in 4.5 ounces versus the 7 ounces, it's gonna be half an hour before you get it versus 16 minutes. So it's just taking that much longer for it to balance. You don't wanna take such a long time that the pH stays elevated, and then because now we're feeding chlorine that we didn't need to feed. We were already at 3 parts per million, but because the pH gets elevated, we start feeding more chlorine, okay? You guys get it, y'all get that? Any questions on that?
Yeah, they're inversely related, so as the pH goes up, ORP goes down. You bring your pH up and it brings your ORP number back up. So if he was talking about 700 millivolts last time, if that pH starts to climb and it drops down to 690, 695, it's gonna start feeding chlorine, even though the parts per million hasn't changed. So as you want to keep that pH balanced, now you're gonna be able to hit your set point and stay with the amount of chlorine that you wanna keep in there.
I think a really common scenario that you see in that, Chuck, is like when you show up to a pool and you've got an empty acid tank. Nothing's wrong with the controller. You ran empty. No big deal, happens to all of us. But what happens there is your pH elevates, you may find yourself with an extremely high chlorine level.
7, 8, 9 parts per million.
So it's like, the idea is don't freak out and overcorrect. You gotta fix the pH.
And I'm gonna
first.
show you ways to prevent you getting massive chlorine in there by that.
Okay,
And I'm gonna show you that. That's part of this whole thing that I wanna teach you guys, is
Yeah.
the proper use of this thing. We have overfeed timers in here, we have lots of things in here to keep you guys from doing that. The last thing you ever wanna do, and that's what I'm saying, don't stress over an 85 gallon a day pump, don't stress over those, because no matter what the output is on it, if we set this controller up right, you're not gonna overfeed, because it's gonna get outside of its parameter and it's gonna shut itself down. Okay, it'll just shut down, you'll see the lights flashing. When you see those lights flashing on both sides here, you went into overfeed, okay? So you gotta set up your overfeed. How do you set up your overfeed? Overfeed's based again on how long it takes for it to satisfy itself. We know if we're pumping in 7 ounces on this 30,000 gallon pool, we said, okay, within 2 feed cycles, it should have already satisfied itself. So why would you put an overfeed time on of 100? It's like, it already satisfied itself at a part per million with 2 feed cycles. So you start out lower to start. Put it at 30, 40. At 40, and you say, okay, well, the maximum it could possibly do. Well, if I'm pumping in 7 ounces for every minute of runtime, and it does 40 cycles, how much chlorine did I put in there that would have took it from 2 parts per million to max of 7? And then you adjust it, okay? You guys get that?
And the overtimer, the figure you're looking at is the amount of cycles.
That's the amount of cycles it's going to do, and I'll get further into that. I'll
Well,
get
real quick on Stenner, before we leave the pumps, on Stenners, you don't have to spend the money on the adjustable. So Stenner has a
Correct.
fixed rate and an adjustable rate. You're gonna pay, I mean, I don't know, a distribution, probably $150 to $200 more for the adjustable version that's got the 1 through 10 dial on
You're
there.
squeezing the tube tighter when you're adjusting that, or it's like?
No, it just changes the motor. The motor, instead of, it's like a step motor, and it steps, so it changes the number of steps that it does. It speeds that up, so it steps quickly versus stepping slowly.
Plus, if you want your pump to
If you have it
last
set at
longer,
1, it's gonna go click,
don't use those.
click.
They do burn quick.
Open it up full throttle and let it ride?
Yeah, if you have that on there already, put it at 10, yeah.
Here's the problem with that. This is the same thing as some of our competition who builds controllers. They put in a thing called proportional feed, okay? Proportional feed was never designed for spas, you guys. It was designed for pools. Why do I say that? Well, if we know that a spa, when we're injecting chemical into a spa, we're turning on the jets. We have hot water, we're boiling the water, right? It's aerating the water. So if you're aerating the water all the time, chlorine's a gas, we talked about that. It's gassing the chlorine off as we're putting it in, okay? So if you have a proportional feed system, it's going on, off, on, off, on, off, on, off, trying to get to 3 parts per million, okay? But we designed in ours, because we knew that was a bad deal. In ours, if we have a 30-second feed, it'll feed 30 seconds and go off for whatever we say our delay time is. It'll sit there till the next time it feeds, and it feeds again. However, if it's 10 seconds into the next feed and it lands on set point, it shuts off, okay? Problem with proportional feed is, you guys, is if you imagine, I don't know how many of you guys have kids, but if your kid stood at the kitchen light socket and went like this all day long, you'd want to beat him, right? Because it's just going to heat up all the electrical, the wiring, it just prematurely burns things out. And so that's the same thing with the Stenner that's got the variable speed. It's on and off, it's on and off and off, so. Yeah, so if if the Stenner's on and off all the time, that's all you're doing is heating them up. And these things don't have a cooling system. Stenner has a grease, Rollicam has oil. And so as we heat them up, all we're doing is prematurely wearing out our pumps, and we're the ones that have to fix them, and we're the ones that have to go through it. So, like Chuck was saying, buy the fixed head. It's specific for controllers. If you're gonna buy the Stenner, Rollicam is straight out. It's gonna work.
Yeah, if you don't use the dial, if you use the switch on the front on the Rollicam, put that switch in the very bottom continuous feed mode. That's what that is. That completely eliminates the dial. You can turn the dial all you want, or I guess it's digital now. They have the digital display on there. So it completely gets rid of it when you put it in continuous feed mode on the Rollicam.
Set that to 1 or 10, you suggested on the dial if you have it.
Well, you always want it at 10 if you're gonna do a Rollicam, but what he's
Stenner,
saying is it has continuous. And if it's a Stenner that's got the variable set, put it on 10.
Yeah. The Rollicam just put it on continuous feed.
Let your controller, that same thing with that Stenner pump, is that was designed originally for before controllers were ever came out, that you could put it on a tube, it would feed in 4 ounces of product and it would wait, it would feed in 4 ounces, it would wait, those types of things. But today that's illegal. We don't want to do that type of stuff. If you got a pump that's plugged into a wall, that's the worst scenario for us, because if the pump goes down, we're pumping all that chlorine and acid into a dry line.
That happened.
It happens. Rollichem was sued for it, so it's not that it doesn't happen, it does happen. So, back to understanding pump sizes. Do you guys get that whole thing on understanding the pump sizes? Anybody have any questions on that?
Bigger is better.
Bigger is better.
That's kind of the bottom line.
And especially, here's the thing, if you're steadfast in the fact that you want to continue to use a smaller pump, like a 45, the 12, you need to go away from. I'm just being honest.
I'll tell you that, just like from my perspective, I'm a liability manager, guys, so I'm not in the field anymore. I'm managing a crew of guys that I believe is great, and that's a great item, but
That's
we all screw up.
reliability right
We're all
there.
human, so I'm constantly building ideas and programs to limit us from first and
liability.
foremost hurting somebody, but obviously being sued as
Well-
well. But I do think that there's some risk in the, when we get into the 38s and the, going up to the big boys, like, start very slow. A 10-second feed time with a pump that big on a spa is probably pretty normal.
Yeah.
I mean, you're gonna see,
Yeah.
so if you go in and put a 2-minute feed time, it's only gonna take
100%.
one time for it to blow through
100%.
too much. So
And that's
just
what we're
start
talking about,
slow,
is
really
understanding
slow.
the ounces of output
Yeah.
for the size of the body of water is. So if you have a 2,000 gallon spa, you only need 2 ounces.
Yeah, it's
So if
very
your pump is capable of 7, you're 100%. You might have a 10-second, you might have 8.4 seconds of feed time. But who cares whether it's 8.4 or it's 30 seconds, if it's gonna last you longer and you can get the number down where you need to be quick, especially spas. We need pH to be back down like that, because it's just gonna overfeed and you're gonna have problems.
Yeah, and a lot of you guys are gonna come into pumps that are already installed, so.
Exactly.
You're not always gonna be able to choose, hey, no, I want to put this pump on there. You might go to get a customer that one of the big builders just got, and you walk in there, they got a 10 gallon a day on the acid, and they got a 20 gallon a day high pressure pump on the chlorine. Like I said, they may not let you replace the pumps, which is fine, just replace the squeeze tube and go with the new.
But understand also that if you do have that size pump and you have to deal with, and that was my next thing I was gonna get to, if you're stuck with a customer that has a 45 gallon a day, say you're using a Stenner or you're using a 38 with the Rollichem, right? But this pool is big. It's a 50,000 gallon pool. Trust me, you're gonna be on a struggle bus with a 50,000 gallon pool. That 38 gallon day pool, body of water or output for a pump really is limited to maybe 40,000 gallons. Okay, and why do I say that? Because like I said, its output is limited, right? And so if you got a 40,000 gallon pool, you need 40 ounces of product to get it to a part per million. That means if I want to get it in half, I need 20 ounces to get half a part. That's a long time, right? So the pump runs long. But you're gonna have to understand that when you have that, you're gonna inherit those properties. I get that, but that's where I'm trying to get you guys to understand. Focus on the output of what your pump is, to understand how much you need to put into that body of water to balance it.
And if you get a
Okay.
pump that's undersized, we also have ORP2 output at the backup. He'll talk about that more, but you have an option. If you can't get them to replace the pumps, maybe you can get them to add a pump on the secondary, on the chlorine side.
If you get over 40,000 gallons, you need to jump into the bigger size pumps if you wanna have quick return. Now, he just hit on something that's perfect, and we're gonna talk about that before I get into the controller setup. ORP2, okay, you have ORP1, which is your primary run. So let's use 700 again on our set point. Say that 700 is for 3 parts per million. I can go in and say my run time, because I know that my properties, Monday through Friday, we're not as heavy, right? It's just a fact. I mean, it's never as busy in these hotels on a Monday through Friday, but it gets really busy on Friday, Saturday, Sunday, right, the evening. So you go to ORP2. Now let me back up. ORP1, let's go with dose
Can you
time.
move that back maybe 3 feet,
Yeah, I'll move it back.
if you could?
Yeah.
I could see it.
Let's just say that this pool's, can you see it now?
I can see it better, yeah.
Okay. So let's just say that this pool is a 45,000 gallon pool, and I've got 180 seconds, which is a 3-minute feed time that's on there, right? And I know that Monday through Friday, I can carry 2.5 parts per million, and it's just perfect. But I know that this pool gets hammered on Saturday, right? Might be a Marriott, might be whatever down here in San Diego, and this thing just gets beat up. You go to ORP2, and you talk about putting a second pump on. So now this ORP2, if you look at a set point, you see how if 700 was a 3 parts per million or 2.5 parts per million. You can take ORP2 and move it all the way up, and you can see that if I try and move that up anymore, we'll go into the set level. If I try moving that up, it won't go any further.
10 millivolts?
It's 10 millivolt drop for ORP2 to work. So Monday through Friday, that pool's been maintaining right on ORP1. Bather load gets heavy, it drops a part per million. ORP2 says, hey, my buddy can't keep up. He's struggling. So you go to your dose time on this guy. And so instead of a 180 dose time, you might say, hey, I'm gonna put in 480 seconds. So now you got the primary pump running 3, you got the secondary pump running 4 or 5 minutes, right? So now you look at the ounces of output between the 2 pumps, and your recovery to bring it back to set point is just like that, okay? It'll happen really, really fast. So if you got that customer who won't change out that pump because it's an expense, convince them to buy a second pump, use the little bitty pump. Now you can go back and buy a pump bigger, use that as your primary, and then use your secondary as the littler pump and know what the output is, and you might have to put in 600 seconds, it might be 10 minutes, whatever it should be.
No, I never thought of that. I always used the RP2 and I have salt.
No, that's what it was
It was a backup
originally.
to the salt
So
system.
Chuck can tell you, when we designed the very first one, I had a Del Webb Sun City that had big giant Chlor Kings on it. And we needed to have a primary secondary. I had two controllers on at one time. One ran the salt system and I'd run them with liquid. I just kept them 10 millivolts apart, and that's how we really came up with.
Yeah,
doing
that's the
ORP
only
1 and 2.
I never thought of that.
So like in that particular pool, eventually we built the 820, we put on ORP1, ORP2. ORP1 was running the salt system. Salt system couldn't keep up. ORP2 would kick on and have a monster pump on it, which would bring it right back up so that the chlorine could shut off. It didn't have to run all the time.
And that'll give you the ability to get through the health department, because the health department wants X amount of chemical per hour or day. So they'll say you can use a 38 gallon a day Rollichem on this pool. So you propose a salt system as ORP1. If you didn't have that backup, they wouldn't let you do it. Like a smaller, like an IC60 or something, because it doesn't have the output. But if you go with ORP2 with a 38, they'll pass it off because it does have that capability for the 38.
Yeah, as soon as the salt system starts to struggle a little bit, and I always tell people, if you're gonna put a salt system on, utilize ORP2, man. I mean, it's like,
Yeah, that's the
it's the
only time
best
I
thing
ever
since
did it,
sliced
yeah.
bread, because I know the recovery's 24 hours on my salt system, okay? But my recovery on liquid is instant. I mean, it's like boom. And the problem is that you can have a salt system and be struggling at a part and a half and get algae, okay? You throw the liquid into there, and whatever comes in there, the bacteria, people urinating in the water, things happen in our swimming pools. As soon as that chlorine hits the pool, the first 45 minutes, it's instantly killing everything that's in sight. So that was the other thing about the eyeballs, you guys. When everything's pushing this way, as the chlorine's entering the pool, it's like a mushroom. It just mushrooms out, right? It's going like this, but the next batch coming down is pushing it. And so you're constantly moving that chlorine through the pool evenly, right?
If you have salt on ORP1, do you like continuous on that dose time, or do you cycle it?
I don't. I like cycling it because I can put my delay on there very short if I have to. But the salt system running constant at 240 volts, things get hot, right? So it's like you almost need to have a little bit of downtime for some cooling off on the transformer, things like that. Plus, like I look at it like this, is if I run it at 15 minutes and I have a delay, and I have 15 minutes and I have a delay, it's getting 4 cycles in an hour. How much am I losing in it shutting down? Is
Just
you have a
cool.
5-minute delay or you have a 3-minute delay, whatever it is, it's 12 minutes. I mean, it's nothing to lose. But if it falls down flat where it needs to catch up, ORP2 will do it for you. Like, and part of that, if it gets up to 70 cycles that it's trying to do is catch up, by that time ORP's already detected where it's falling behind, and ORP2 comes on and runs a pump. As soon as that body of water gets to set point again, that overfeed timer resets itself back to 0. Okay? So remember that, you guys, when you're using that overfeed timer, if there's a feeds, say you had 40 on there, and 20 20 cycles, it finally hits set point, boom, it goes back to zero.
Yeah.
Okay, so you're not gonna be still into that 40, it's for like an all-day affair, it's only 40 to get it to set point.
What if you have a pool spa combo and you're saying you're running it for, you know, just throwing number 600 minutes for the complete body of water, and then they go to the spa? Is that gonna be able to adjust for the smaller body of water as well?
So you're talking about a residential pool?
Residential.
Yeah, I wouldn't typically put a residential pool at 600 seconds.
Yeah.
You're gonna generally,
it out there.
because you have lower bather load, I mean, maybe on a Saturday or on a weekend, you might have but I would say generally, we would recommend running a little bit lower and having to cycle a few more times than in a commercial environment where you could completely turn upside down on that pool very quickly. On residential, you have time, and you have more time to recover,
Yeah,
so
and it's-
I would say you
It's
would
not
go
a
with
national
a.
emergency in a residential pool.
Yeah, I would go lower on your dose times, even if it means more cycles in order to maintain.
And that's, in that note too, would you be putting it on the common line, you know, rather than just the pool site itself, because you still want some type of sanitation?
But here's the problem, putting it on the pool, on just the pool. When you switch over into spa mode,
Right.
now you have, now your flow switch is still active. The controller still sees that water coming through here because you're cycling now in spa mode, but it's injecting the chemical over into the pool, and you're got
And it's a large
static.
dose.
You got a static line, so we don't
If you had 600
recommend.
seconds, you'd be dumping 600 seconds into a spa.
Yeah.
It'd be nuclear.
Yeah, we
like
don't,
that
so,
fast.
so that's kind of you have to be careful about that. We always, we recommend that you put the injection point prior to the three-way on a pool spa combo. But because of that, you are gonna be injecting at the same dose time that you would be in the pool, when you're in pool mode. So just be on the low side in terms of your dose times.
Understanding pump sizes, you guys, back again to that. I gave you guys my card. When you guys are out in front of a controller, the easiest way for me to teach you and to fix it is that you call me when you're standing in front of it. Don't call me when you left the job site and go, hey man, I was over there and it's not kept keeping up, it's doing this, because I'm gonna say to you, well, you got to go back to the job, I can't help you fix it until you're standing in front of it. I wanna see what your run times, I wanna see what your delays are, I wanna see what pumps you're running. Tell me the last time that you put a squeeze tube in. We're gonna get to all that maintenance part and further on down here, but call me when you guys are standing out there, because I want you guys to be 100% successful and that you're landing at the set points and you're doing all this stuff, because if you're anal like me, you can, I mean, we designed this for a reason, to get you there, to get you to a finite number that you can get to, but it's getting that right feed time and the right size pump for the acid so that it stabilizes. Because if your pH is constantly doing this, you're never gonna keep ORP there, because it's gonna do this too. So we wanna lock that, okay? So use my card, call me. I love talking about this stuff, I'm passionate about it, so I'll spend any kind of length of time you want on it. All right, controller setup. We talked about pump sizing, this is where it comes in really important. Every single controller, you guys, is going to have different numbers. Okay, it's gonna have a different set points, because every single body of water is its own living organism, just like the human body is, okay? You guys are taking care of a living body, basically, all right? So if you walk into a pump room today and it's reading 700 and it's 2.5 parts per million, today, 700 equates to 2.5 parts per million. You guys come back a week later, you do service, you see 700, but you got 1.5 parts per million, okay? Something has suppressed the ORP. We either had a rainstorm, a windstorm, we've had heavy bather load, people urinated in the pool, so you have urea in there. There's lots of different things that will start to suppress it. You might have threw in a little bit of conditioner, okay? Conditioner's gonna lower and suppress your ORP. TDS, total dissolved solids, is going to drive your ORP down. I explained total dissolved solids as this. If this is a snow fence, the higher the TDS gets, this closes, okay? As it closes, we don't freely move water through it. So our ORP doesn't read as well when we get heavy TDS as when we have it with fresh water. You'll notice when you put in fresh, you dump a spa or a pool, and you read 800 ORP. That water's as fresh as can be. It's like, that's the best you can get. As it starts, you can walk in a pump room, and I can look at someone says to me, hey, I got 3 parts per million, but I'm reading 600. I go, you either have a hell of a lot of conditioner in there, or you've got major TDS. Okay, I don't even have to test it. I know that those are the two things that are driving that thing down.
Which salt is part of that too.
Salt
so
is
that's
part of
a big
that.
part, yeah.
So you guys know too, there's good parts of salt and bad parts of salt. So TDS, if you have a TDS meter, you also have to have a salt tester so you can test the salt, because the salt's not gonna be bad TDS for controller. Yes, you'll run a lower ORP number, but it's not garbage like we have in garbage TDS. So you have organic and inorganic also that's in TDS. So organic we can kill with chlorine, inorganic we cannot. Okay, so it's gonna be there.
And to be clear on CDS and just the variables that will adjust your ORP level, would you expect a ORP value to be higher or lower if you have, high cyanic or high TDS to achieve?
Lower. ORP will always go down.
So you'll
It
see,
suppresses
say, a
it.
600 millivolt reading may give you 3 parts per million.
Correct.
But you would actually like to see an 800 millivolt reading giving you 3 parts per million. That's
Anything from
available.
700, 725 up to 800 is always gonna be a nicer, cleaner water. I mean, so, you're gonna get into these customers who are saying they don't wanna dump water, they don't wanna dump water. It's like, I always tell people in those cases, because I've had directors of engineering say to me, well, we just can't dump water all the time. I said, well, okay, when you go home tonight, you take a bath and tell your wife you wanna save money. So you're gonna say, hey honey, can you go take a bath now before we dump the water after you've already took a bath? She'd look at that and say, hell no, I'm not sitting in there. It's the same thing. Because we're putting chemicals in and we're using filtration, doesn't mean that all the garbage is not still in the water.
Our commercial spots should be drained more often than not.
100%.
Yeah.
100%. If you went through any classes on understanding that, you'll see how the fecal discharge into a spa is ridiculous. So, it's, I don't even let my wife and kids swim in those spas. Okay, so TDS is a bad thing. It's gonna drive ORP down. So when I get to what I'm saying to you is that you walk in a pump room, I hear this when I travel across the country, is I go, well, we're told that it needs to read 750. That's an impossibility. Who's ever told you that? The health departments in some of these places, that's what they tell them. And it's like, if you had to maintain 750, you'd be dumping water all the time. Like, just to constantly keep it at 750. So don't be afraid of the number that's on there. As long as you're getting the result you're looking for, okay? If you see the TDS climb, you're gonna already have clarity problems in your pool. You're gonna see your chlorine's not working as effectively. You're gonna get algae. You're gonna get all that stuff because that's how it lives. All right, so when you see TDS get high, you see it getting up in the 2000, 1800, 2000, start dumping some water. Back to waste, those types of things. So TDS is going to affect where that ORP is. So don't freak out when you see one pool at 800, it's 3 parts per million. You go to the next controller and it's reading 725 and it's 3 parts per million. That day, that number is what it's reading at 3 parts per million, okay? So you walk into that pump room and that one that I was telling you is 700, and now it's 2.5 parts per million instead of being 3 where you want it to be. Well, you're gonna raise your set point up. Either 5 millivolts, you're gonna raise it 10 millivolts. You raise it up 10 millivolts, you're gonna get another part per million, okay? So once you've established your run times, you guys, and the squeeze tube is good, the only thing you're going to be adjusting is going to be your set points. If it's getting too much chlorine, and say it's reading 720, and you want it to be 3 parts per million, you're gonna say, all right, well, I'm at 4 or I'm at 5, take 10 away, and it's not gonna feed a thing until that number drops down to that again, all right? So it's really, really simple. A lot of people freak out on ORP and they make it so complicated, and it's really the easiest thing in the world, is just understanding that whatever it's reading when you walk in that pump room, I don't care if it's a part per million, it's reading 700. Take it up 20 millivolts and your set point at 720, it's gonna get 3. Now, the other side of that is if it's reading low, do not make massive adjustments. Okay, I have this with a lot of guys. They'll go in and they'll move it up 40 millivolts. Don't do that. It's not emergency that you get it up to 5 parts per million or 4 parts per million or wherever you're trying to get to. Is move it up 20 millivolts and let it settle out where it's at. See where it goes, and the next time you're there, make it one more adjustment. Because it's a lot easier to take chlorine up than it is to take away. Okay, you're gonna have to put in thiotrine, thiosulfates, then all of a sudden the pH goes low, it's a pain in the butt. Do small adjustments, don't make massive adjustments, okay? Especially the good thing is if you're using ORP2. If you're using ORP2, you move that to 20 millivolts and you bring it up, If it doesn't keep up and it drops down, it's gonna give you that, bring it right back above the set point where you wanna be anyway. So I always set my ORP2 up so that I'm actually going, if my set point is 700 for 3, I know that the feed time that I'm gonna do on ORP2 will be long enough that it'll take it actually above 700, maybe to 710. Because then I know it's gonna, the bather load's heavy, it's gotta work its way back down before ORP1 kicks back on, all right?
Do you suggest making those adjustments with like a liquid chloride or a dichloride? Because first day I used a broadcast dichloride in my commercial spa the other day, and it went south real quick.
Yeah.
And I wasn't able to chase that, it just didn't, it would turn
Use your liquid.
Gatorade color. And
1 ounce of liquid chlorine for every 1,000 gallons.
it didn't like the dichloride, that's for sure.
No. So if you got a 2,000 gallon spa, 2 ounces is gonna get you a part per million, 4 ounces is gonna get you 2. It's easy. It's the easiest thing. In fact, I always joke about this, and
So use a measuring cup.
whether you're using Cal-Hypo, you're using trichlor, you're not using dichlor, I tell people, okay, well, I want you to take a scoop out, and I want you to give me 3 parts per million in this spa. As good as all of us are, we can't do it. We can throw in some and it's gonna fluctuate, we might get a 5, whatever. But with liquid, you can get that, because it is fact. 1 ounce of liquid chlorine for every 1,000 gallons gives you a part per million. You can get 2 parts per million. So it's easy. You can give any employee and say, hey, where are you at? I'm at a 10,000 gallon pool, all right? Put in a quart, you're gonna get 3 parts per million, you'll be good. So it's super easy to do. Any questions?
Yeah, so you're talking about changing the ORP. Now, that's with the pH at a constant of 7.6.
That's the assumption.
7.5, whatever you're trying to settle at.
Whatever it is.
Whatever your set level
Whatever your
is, yeah.
constant is for making that.
But this is what I'm
change.
getting
Because
to
you're gonna
next.
have a higher,
Yeah, don't walk
pH
in-
or lower pH, and then you're making
Nope.
those changes.
Yeah,
that's what you
wanna
don't
make
wanna do.
sure-
Yeah.
Right.
Yep,
okay.
that's what you don't wanna do.
I just wanna make sure that it's clear.
Okay, so what I do, you guys, and when I set my controllers up, the first thing I'm gonna do is I'm gonna go into that pH. I told you initially how I establish what my delay time is, right? I go out to that spa or that pool, and I throw in product, and I wanna see how long it's gonna take to come back. Once I've established that, okay, I am going to, now I know I'm already elevated, right? I'm at 7.6 or 7.7 because I put soda ash or I put sodium bicarbonate in there. Now I wanna see how long is it gonna take me to get to my 7.5. So I sit on a bucket. I know roughly how many ounces based on my output of the pump that I'm using it's going to take to put in the product. Now, if you're looking at acid, what I told you about the Taylor test kit is, or when the Taylor test kit, if you wanna decrease, where's that in here? If you wanna decrease a pool using uric acid, it tells you how many ounces. Okay?
That's at a certain percentage, so now.
That's at
one of the-
straight.
Yeah,
That's at
that's
straight.
straight, because one of the questions for, you know, well, it's more of a statement, but to keep or reduce corrosion in our equipment rooms without having to use a scrubber, you know, we're getting it diluted to the 15%, I think is what it is from the.
We want 4 to 1 is what we recommend.
Well, if you're mixing, we could actually get it directly from HASA, pre-diluted, so,
Yeah.
too, but then.
Yeah, so if you're buying the pre-diluted, you gotta go by what you're doing with pre-diluted. I can tell you that the 4 to 1 for me, if you're using 4 to 1 acid, you guys, when you dump acid into the barrel is when you're getting most of that agitation that happens, you get the fumes. You can go to an acid barrel that's been sitting stable all day long and put your nose right over the top of it, and you won't smell anything. It's only when it gets agitated a little bit, it gases off. But 4 to 1 acid, so depending on whatever acid strength you're using is what you gotta know what your volume is. But if you look in there and it says you need a quart, you gotta look at, okay, I got 4 to 1. I'm gonna have to put in a lot more product than that to get it to there, right? So you need to establish that number first to find out how much it is, and that's with your dropper. Test your 7.6, your 7.6 says you need 1 drop, it brings it to 7.5. So then you go in across here and you say, okay, it's a 30,000 gallon pool, you put the 20 and the 10 together, it tells you how many ounces you're gonna need to pump. So I go to my dose time and I might say, well, based on what I see there, I might need a 1 minute dose time to get the acid in there to bring it from a 7.6 to a 7.5. So I sit down in the bucket and I run a full cycle. Goes in its delay, nothing happens. I didn't see any change. So I run it a second time. Second time comes back, it didn't change. Now I'm getting too long. I've got a 60-second feed, a 5-minute delay, or a 7-minute delay. That's way too long for it to not start coming back down to balance, because I'm gonna be in the ORP is gonna drop and it's gonna feed too much. So I'm gonna go in there and go, okay, I obviously don't have enough dose time, so I'm gonna go up to 120. I might even go 180. I run it to 180, I'm sitting on the bucket, and all of a sudden I start seeing my 7.5 start fluctuating, right, coming from the 7.6 down. And I go, sweet. I know that that's gonna be where my sweet spot is, it's gonna bring it from that. Now, why is that my sweet spot? Because I can assure you guys, if you set these up right, you will never get a 7.7 in pH. You shouldn't. If the dose time is correct, as soon as it leaves 7.5 and gets even close to 7.6, it's gonna start feeding that dose, okay? It's gonna feed it, and we already know, we've established that at 7.6, we brought it down, in 3 minutes, we brought it down to a 7.5. So it's gonna feed that dose. If it didn't, it would go into that second feed. So that's why it's really important to establish that pH first. We wanna know that we're locking it in from that 7.6 to a 7.5 quick. I can tell you, I mean, I don't know how many you have, but you'll see, this thing wants to be at 7.5. I mean, it's just what it does. And the longer it takes, if you have the smaller pump, then it takes that much longer. But you don't wanna have these long feed times on liquid, because liquid's high in pH, if your pH isn't coming down with your acid feed fast enough, because you're gonna overfeed. You're going to be constantly below on ORP and feeding too much. So take the time when you guys do your initial setup. I know it's a pain in the butt to sit on that bucket and watch it, but if that little bit of 15 minutes that you spend is going to be heaven for you in the future.
You gotta
Okay.
remember too, if your alkalinity, you gotta make sure you've got good alkalinity. You see
Absolutely.
something balanced, like, you may
It'll
sound a
be go
perfect
crazy.
dose at perfect time, but that pH value is going to move very quickly.
Yeah, so it's really important that you're keeping your alkalinity between the 70 and 100. You know, if you're keeping alkalinity and the alkalinity starts running down at 40, you're exactly correct. You're gonna see it bounce big time
Probably
with
one
just
the
a
most
small
common
amount of
things
acid.
we see. You know, everybody assumes, hey, if the digital numbers look good, then you're good, but we have to manually check your, you know. like-
Well, and you guys know that between 70 and 100 is the only time you get true pH. Okay, so when you use your phenol red, you're only getting a true reading when you're in that 70 to 100 bracket. If you are reading 40 in alkalinity and you test 7.5, you're really not a 7.5, you're probably more like a 7.3, okay? And so that's really, like what he just said, is really important, because you're gonna get that pH bounce really, really fast.
So you're still keeping the delay at 5 then when you're doing that too, or you're also
Well-
making?
well, no, I've already
adjustments
established.
To that too?
I've already established earlier on when I talked about the shape of that pool, I threw in my sodium bicarb and my soda ash. I wanted to see how long it was going to be. So I knew that was a 7-minute delay on that particular body of water. Now I fed out my 3 minutes, and I should be landing where I need to be. Okay, after I establish that, I'm gonna go into my delay time. I already had that at 7 minutes. Now I'm gonna go to my overfeed. If it's a 30,000 gallon pool, I know that at 180 seconds, I'm feeding X amount of ounces on it. I knew that, okay, 2 feed cycles brings it down. So to start off, don't be aggressive when you first start off in your overfeed timer. We wanna know that, hey, worst scenario, if I fed 30 times this acid dose, where could my pH end up, right? If you come back the next day, or if you're using the Wi-Fi based, you'd be able to see it that night. Okay, you'd be able to go on there, you'd be able to look at it, and you'd see that you're sitting at a 7.2, this is not good, right? We have too much runtime. It's super important that your delay time is not too high. You don't wanna feed in too much product, but you don't wanna feed too little. So say you start out at 30, 35 on this particular body of water. If you came back and both lights are flashing, it was overfeed. Okay, well if it's overfeed, let's hold off a second. Why did it go into overfeed? Well, maybe we don't still have enough runtime, right? It's taking too long for it to satisfy itself. So we might not mess with our overfeed. We might go back into our feed again and set our dose time, and we might add a little dose time to it. And now you say, oh, well, now it's ending up too low. So then we gotta go back to our delay and change our delay. So there's where, when you guys talk to me on the phone, we'll play with all those types of things so you can get it just right. Because not all the time is it gonna be the overfeed problem. The problem might be that it's not getting enough feed, or your delay might be just a minute too long.
Or the most common cause of that flashing overfeed is no chemical. So when you run out, it'll cycle, whatever that number of cycles is, it'll cycle, and then it's not doing anything because there's no chemical. It'll go into that flashing.
define
So
what
first thing to look at is the,
Huh?
Define overfeed.
Okay, hang on, I will, but just hang on to that for a second. If you're using the Wi-Fi, you guys, and you're using this number, this is what's great about the Wi-Fi, is that you guys can be at home, get done with dinner, and you can pop on your phone, or you can pop on a laptop, and you can look at what that pool's doing all day long. You can see, hey, it's been landing at 7.5. We know our runtime's good, and all those different things. And you say, well, it's never getting to 7.5. It's constantly staying above. I mean, we have either too long a delay or we don't have long enough feed. Okay, so that's the beauty of the Wi-Fi. Overfeed time. So we established the fact that my dose time was 2 minutes and my delay was 7 minutes. That's a 9-minute cycle, right?
Okay.
It's gonna do that, whatever you establish on your overfeed. So if I take this overfeed down and I say, well, I'm gonna start out at 40, it's gonna feed a 9-minute cycle. It's gonna do another 9-minute cycle. It's gonna do that 40 times, trying to get to set point.
Okay,
If it can't do that in that 9 minute to 40 cycles, that's telling you you didn't have enough runtime
yeah.
or your delay is too much, and then you might have to play with those first before changing your overfeed. And then after you establish that those are good, maybe we do need to add 5 more cycles to it.
So the
But
overfeed is how many times it's trying to kick over, then if
to get satisfied.
to get satisfied.
And once it
Doesn't get
satisfies,
there.
it goes back to 0.
That'll repeat, okay.
Okay, but again, that overfeed, you guys, is really cool about that is if you get to overfeed, if you didn't have Wi-Fi and you get to overfeed, it's telling you one of two things. You don't have enough runtime, the barrel's empty, or your delay is too long, because it should be getting satisfied relatively quick. It shouldn't take 40 cycles to get there.
I'm sorry.
What that 40 cycle safety is if we have a 15-gallon carboy that we don't dump in 40 cycles, we don't dump, if you had that at 80, that we don't dump excessive amount of product in there to hurt somebody.
yeah,
Okay,
it's
so
going
that's
into
your first
overfeed, that indicates, like Ted said, there's something wrong either in the program or your chemical's empty. So it's a good signal to tell you that, okay, you need to adjust something. That's what that flashing number means, that something needs to be adjusted, or
Okay.
you're out of chemical.
So, on your high alert, low alert, okay, these are another really cool feature. The high alert feature is that if it gets to 7.8, it's not gonna feed anymore. It's gonna go into alarm if I have my overfeed at 7.8. And it's gonna tell you probably the barrel went empty, the squeeze tube failed, something's not working right, okay, for it to get to 7.8. Because we originally set this up, we knew that if we fed it for the X amount of period of time with our delay, that it was getting satisfied. It was bringing it from 7.6 to a 7.5, just like that. Well, if it did that, and there's no reason that we would have an 8.0 or an 8.2 or 8.4 as your high limit, because we knew it should have been satisfying really quick. So you can take and start running these high alerts down a little bit lower, saying, hey, if it gets to 7.8, I'm not gonna feed anymore. Well, why did I do that? 7.5 to 7.6, ORP is gonna drop 5 millivolts. 7.6 to 7.7, another 5. 7.6 or 7.7 to 7.8, another 5. You dropped 15 millivolts in ORP, it's gonna keep feeding chlorine. Okay, and it's just gonna keep driving the pH even higher. So that's why the lower you can keep that and make your tolerances good, as long as you get your setup just right, you won't have to run a super high alert on your pH, okay? We put the 8.0 in there as a standard. That's so, if a guy doesn't want to sit there on the bucket and watch that his pH is establishing it, it might feed 5 cycles in ORP and it drives the pH really high, and it takes that much longer to come down, but his ORP is going to keep feeding. It's just going to do it. So this eliminates you heavy dosing, okay, in that ORP. Your low alert.
Let me just inject something here. When you go into high alert, so if you are at, in this case he has it at 7.8, if you're at 7.8 for 10 minutes, it's going to go into alert. So you're going to know it's in pH alert because there's a little alert light that's going to turn red. So what happens when that turns red is it stops feeding everything.
Chlorine
It
and
stops
acid.
feeding chlorine and acid. The reason it stops feeding chlorine is what he's described earlier. As the pH starts rising, your ORP is dropping. If we didn't shut down both sides, it would just keep pumping because the pH is keeping, for some reason, it's going up. Either you're out of acid, it's going up. So that ORP is dropping, it's injecting chlorine, and it's gonna keep doing that. If we don't shut everything off, you're gonna end up way overfeeding on the chlorine
And it
side.
saves you money not dumping in chemical uselessly. I mean, that's where it comes down to. So, back again, the pH is the king of this whole deal. If you can get your pH established where it lands at the 7.5 and stays there, this number really is irrelevant because it should never get to a 7.8. You should never have where the ORP drops down 15 millivolts. The only way that's gonna happen, and we're gonna get into that in the maintenance part of it, is squeeze tubes bad, barrels empty, that type of stuff, okay? Your low alert, you're gonna see it when you get a controller, it's gonna be at 7.0. We know that 7.0 is neutral, anything below 7.0 gets corrosive and could start eating up heaters and things like that. So I myself, in my controllers, I never used 7.0. I always used 7.1, 7.2. I never liked 7.0 because if I'm getting that low in pH, I got too much runtime. I mean, basic. Or you're not maintaining the barrel, this is where we're gonna get into the maintenance part, at 4:1. Okay, this is really, really important. This controller does not know when you guys change the dilution of your acid. If someday you put straight acid on there and you had it set up at 4:1, you're gonna be dropping pH out the bottom completely, okay? So it's really important. Every single one of my guys had a bucket on his truck. There was a mark at 4 gallons. They could put the 4 gallons of water in there, add a gallon of acid, and top off their barrels. And it always stayed at 4:1 acid because it's key. This controller has no clue that you didn't keep the dilution ratio where it is all the time. So if we establish it for a 2-minute feed time on 4:1 acid, and then we go to straight acid, it's nuclear and it's going to drop it really, really low. And the other side of that is that if you don't dilute it at 4:1 and say you go to 6:1, you don't have enough, well, it's not gonna keep up. It's gonna keep the pH elevated and you're gonna overfeed in chlorine, okay? So if you really, really wanna be dialing these things in, dial in the fact that you're using your 4:1 acid, and that's all you do, if you're setting it up that way. Now, like in your situation, while you're buying that, is set yours up based on that dosage, you know, what
Yes,
you're.
exactly, and then it's consistent.
And then it's
I don't have to worry
consistent.
about- yeah,
100%.
I don't worry about forgetting, did I pour 3 gallons in or?
Correct.
Because the containers we have too are opaque, so you can't really see, it's
Exactly.
hard to see.
Is there a need to dilute the chlorine?
Never dilute your chlorine.
So I'm gonna disagree a little bit with Ted on this, because with the people I work with on the phone a lot, I leave it at 7.0 when I'm working with guys. I leave it at 7.0. He's correct about everything, but when you have, if your window gets too short, too small, you're gonna end up going into alert on the low side. And if you do that, it shuts off the chlorine as well. So I encourage customers that I work with across the country to leave it at 7.0, but I know Ted, his experience has been a little different, but that's my,
Well,
that's my 2 cents.
I'm only telling you that because I'm more anal on everything, and I'm gonna get into that in the maintenance part of it about your squeeze tubes and all that different stuff, but I established that runtime in my pH that I knew that whatever minutes of runtime I had on there with a brand new squeeze tube was going to keep me at 7.5. We deal with a lot of people who call up that do not do this proper maintenance. What he's talking about is you get a customer who does not maintain the 4:1 acid. They also don't maintain their squeeze tube, so that they put the original squeeze tube in there, and 4 months later, they're calling up and talking to Chuck or I or Danny, and going, hey, when I put this thing in, it worked fantastic, it doesn't work anymore. Okay, let's back up. Let's talk about some maintenance. When was the last time you changed a squeeze tube? Oh, I gotta change those? Well, yeah, it's like the tires on your car, they only go so long. So yes, it's important, those maintenance things. So those kinds of people, we get these small hotels, they're, little podunk town someplace. Yeah, the 7.0 is deal. But for you guys who are the professionals that are out there doing this, if you set them up right, you're not going to see this. And that's the greatest part about this class for you guys, is that learning how these proper setups are, learning, making sure your maintenance things, your squeeze tubes, your injectors, and all these different things. A lot of these properties that he's talking about that people will call, they've got zero training.
Do you suggest swapping out the tubes after 3 or 4 months
3
regardless?
months.
3 months?
I'm a 3 or 4
Okay.
month kind of guy.
Yes, just-
I use a little printer and I print right and I put it on the side, on the wall, or I put it on the side of the controller.
3 months.
I put on there the date that I put in the new squeeze tube, and at the end of the 3 to 4 months, I don't care that those things are 17 bucks, 18 bucks, whatever they are. You know what? It's a lot cheaper to spend 17 bucks than drive across town to fix it when it's taking a dump. It's a lot easier, and it's gonna be, you can be enjoying a beer on a Saturday and not have to make a freaking quick stop out someplace to fix something. All right? So Chuck's correct. If you have a little property that you know, like a Red Roof Inn or one of these places, you know, where they don't have a guy, you leave it at 7.0 because he needs to have a big parameter of things. So, right size pump sizes, get it down to where it's exact, and then you can start playing with these things and get your high alerts and low alerts. I'm super anal. I taught every single one of my guys to be exactly the same. I don't care when you set it up. I don't care what it costs for your hourly wage, because it's gonna be less hours I'm gonna ever pay you if you keep it right, right? Time is money. We need to be on to the next job and not be having to be fixing stuff all the time. All right, so that's pH, ORP. You guys, so back in the pH, when you do your initial setup, the whole part that's cool about this controller is, let me go back to that. We did our setup on pH. We did our set level, say 7.5. We did our dose time, delays, all this different stuff. On those buttons, after you did your initial setup, you will never touch those buttons again as far as your feed times and all your delays, unless it's in the very beginning where you're trying to dial it in. After you've dialed it in, when you come back and do your test with your phenol red pH, right, you're gonna go mode button to pH. The far right button is pH calibrate, right? So if you read 7.7 on your test and it was reading 7.5, you would move it up to 7.7, and now it's gonna feed until it gets back down to that 7.5, okay? So that's the only button you're gonna touch after you've established all those in the
And
beginning.
make sure when you do that, make sure you're taking the test right here. You don't want to do that because you stuck your hand down by the return line and it just fed, and it's looking a whole lot different than it does when it's mixed coming out of here. So don't calibrate pH unless you've gotten your test sample from this center valve here.
'Cause you have
That's
to
what
post to the
the
center.
probe is seeing.
Sensors,
Yeah. Now, the other thing too is if you come back and the controller was reading 7.5 and you've got a 7.7 or 7.8 in your physical test, okay? Remember, did someone throw sodium bicarbonate in there? That type of stuff's going to do that for you, all right? But if it's just moved on you, okay? Then make sure that after you've established that number, that you don't just go in there to ORP and start doing a bunch of crazy things in ORP, because remember what he said, as pH comes back down when you've taken it from that 7.7, 7.5 and stuff, if you've made too much of an aggressive movement in the ORP, it's going to overfeed or underfeed, okay? So that pH has to come back down. So when you start getting good with these things, you'll realize if I'm at 7.6 and I go to 7.5, that's at 5 millivolts. Just change the ORP by 5 millivolts.
It does take some time, right? Like when you do your pH calibrate, say you're coming down 3 points or whatever, you're testing 7.5 and it's reading 7.8, and you go and reduce it. You're not gonna see an instant change on your millivolt value, right? You need to give it some time for the.
It's got a mix.
Well, the millivolt value is going to be based on what the actual pH is. So the millivolt value has nothing to do with what's displaying on the controller. It's what's actually in the water. So it's a physical reaction between ORP and pH. Has nothing to do with what's displaying here.
What causes the drift then?
So let's say if it was reading 7.5 and you had 700 millivolts, if I took it to 7.8, you would not see a difference in the millivolts. It doesn't change the millivolts. It's only if the water actually goes to 7.8, then you're gonna see that ORP number drop.
Okay.
So you're gonna see that bounce, because if you fed in some acid, and it's a slow process if you're using a smaller pump, you fed that acid, you're gonna get a little bit, because remember, it's skimmers and main drains. You might get a little stronger dose at some point because of the way you have your eyeballs pointed or how it's mixing. And so all of a sudden, a little bit heavier dose of acid comes through, and all of a sudden you see this fluctuation, and then it goes away because it's clearing the cell. Once it clears the cell, but once you've established a true 7.5 back in the body water and it's constant, it'll stay constant. You're not going to have that fluctuation.
So the pH calibrate function though, when we are calibrating it, you're saying it's because there's inconsistent water being read, or is there actually a drift on what the sensor is reading?
No, well, it can be, over time, those sensors do age. We expect to get 18 months to 24 months out of sensors. You can get 3 years in a lot of cases, or you can get 14 months. But as that pH sensor ages, the readings are going to fluctuate a little bit more. and that's when you can use the,
Here's the other thing with that
to
too.
calibrate.
So, on the end of this has a little clear bulb. If you look at it, it's a little glass bulb, right, that's on the pH. If you have a body of water that's high in calciums, high in TDS, high in all that type of stuff, where you got a property that's heavy bather load, and people are putting tons of sunscreen on, I trained all my guys, when it's in the flow cell, I point this little open area here to the front with a flashlight to shine in there. If it's not crystal clear, and you see a kind of a calcium buildup on it, like it gets cloudy, pH isn't going to read right. So when you see that cloudiness get on the end of that ball, pull it out, rinse it in 4:1 acid, rinse it afterwards with fresh water so it gets all that acid off of there, stick it back in, and then give it a few minutes and let it settle back out.
Scrub
But
or no scrub?
he says to scrub it, trust me.
You know,
I say
everybody
what?
says something different.
You say to clean them with a brush or whatever.
No, never say brush.
Or don't rinse
No.
them.
If you have a heavy oil buildup, the acid's is not gonna be as effective against an oily buildup as it is calcium. So I recommend, and in the manual we recommend, make a little soapy solution, swish it around, that gets the oil off, rinse it, do a quick dip in your acid, and rinse it off and put it back in.
So Dawn
Because
soap or acid mixture, but no brushing.
no brushing, throw away the toothbrushes.
4:1 generally, I can tell you right now, 4:1 acid, when you wash it, it wipes it out. If you, the one that's really the big indicator for you, like when he's talking about with oil, when you do the ORP probe, you guys, it's a silver piece that sticks out of the bottom of the probe. When it goes yellow, that's oil. So if you do the 4:1 and it doesn't come off, then he's 100% correct that you need a little soap to get that oil off the tip of that.
Can you do it on both sensors?
Both
Or
sensors.
just-
Yeah, I mean, I've been doing it 20-some years and doing the 4:1 acid, 99% of the time it doesn't. I have had it where that yellow on the tip of the ORP probe will not come off because it's the oil, it's a heavy bather load, especially spas. They get nasty because they lather themselves up, right? They come from Canada and come here and load themselves up and they look like they're white, right? And all that shit gets into the body of water. But when it gets into the body of water, it's coming right back through your pumps and your filters and everything, and it gathers on the tip of that probe. When it gets on the tip of that probe, that's when you're gonna see it. Especially if you start seeing ORP drift.
Do you think enzymes can help in that situation? Do you ever use it, fan of them?
I'm gonna be honest with you, I love enzymes. I'm not a huge fan of them in my commercial pools. Why? It's not because they don't work. They're expensive, and we're dumping water a lot. We're backwashing a lot, especially if you're using sand filters and stuff. And so, if you're buying, say, the Orenda product's a great product. The problem is that I found with my commercial pools, if I'm dumping water a lot, because I want to keep my TDS in line, I want everything to be good, I want my calcium to be 250, 300. If you're putting enzymes in, you're washing them down the drain, okay? I changed out my spas on commercial every 2 weeks max. Okay, I was
Use
just,
water every 2 weeks?
every 2 weeks I dumped a spa. Yeah,
This is
and
heavy use commercial though.
Heavy use commercial. Not your smaller hotels and the different stuff, but just remember, for every 78 people that sit in a spa,
Yeah.
you got nasty. And this can be a weekend.
Probe.
Right.
So
What about,
Oh, good.
on the probes, are you doing the same thing with like the flex tubes where you're just changing them out every couple of years? Or what is giving you an indication of when
Perfect,
those probes
perfect,
need to
perfect.
be replaced?
I'm glad you brought that up. So, you guys, right now, if you have any of these black tubes, black probes in there, these are our older probes, okay? We've now went to a yellow body probe, and that's a perfect question. I like this yellow body probe, okay, because how do we know when our probe is going bad? When it fails, right? There's two indicators of an ORP or a pH probe going bad. One, you can't calibrate the pH. It starts locking up where you can't go down below 7.6, 7.7. That's one of the indicators. Two, ORP will be reading down at 500, something like that. It's gone, okay? Now the beautiful part is what the yellow body is that you have a reference gel in here. These are just like a battery of a car. That reference gel in the clear one, now you can look in there and see the reference gel. And as the reference gel starts to come down, okay, and you have this into this body of water, when it gets down to the point where it's at the top of the black right there, order yourself a new set of probes.
Have you found any
Okay.
variables that can wear gel down? I mean, we do
100%.
PPM stuff.
We're gonna talk about that, okay? So here's part of the maintenance. When you guys backwash, when you clean a pump basket, when you
do filters, whenever you're doing anything where you're shutting the system off, it is absolutely imperative, okay? This was one of my anal things that I yelled at my guys about, okay? I bought these. These were included in my contracts. So I didn't want to have these fail. If you close those valves and you turn the pumps back on, get everything operating the way it's supposed to be after you've done a basket or you've done filters, whatever. Now the system's working again, right? You slowly open those valves back up. Why do I do that? Well, I'm gonna use Pentair as an example. We have a PS 1000 pump seal in a Pentair pump, right? Say it's a horse and a half. I can pull water from that building over there, where the pool is, to the pump through a 2-inch pipe, because the pump seal's good. If the pump seal wasn't good, we wouldn't pull as much water, right? It takes forever. That's one part of it, it's pulling the suction so much. We also get cavitation in the pump, you guys, when the water back feeds, okay? You aren't putting check valves in the front of your pumps, and you're not doing certain things to keep the water there. So as it cavitates and it's filling up that pump, it's sucking really hard, boom, boom, boom. Well, what do you think it's doing through that little 3/8 inch tube that this is put into, and then it goes into that flow cell? It's pulling really, really hard. So as it's pulling really, really hard, that reference gel is being pulled out through this little frit at the bottom here, okay? So you will definitely increase your longevity in your probes if you shut those valves whenever you turn off a pump and turn them back on, okay? Super important to do.
The other thing to be really clear on is that anytime you open this middle valve, when the system's operating under normal conditions, pumps running, you want to open this valve, and if you don't get water coming out of there, if you get bubbles going in there, you need to adjust. That typically would be the scenario when you're running this off of suction. So you've got pressure coming in and you're running this over to the suction side, which is fine, fine to do. But if you don't adjust this valve down a little bit so that you're still getting water, you're gonna pull a vacuum in this all the time. You'll still get readings and everything will be fine. You're eventually gonna destroy the probes because that's gonna pull.
So what he's saying is you
pull a
guys,
vacuum.
you've seen them, right, where, say it's again back to a whisper flow pump. When you take this line that's coming from here and we go down to the front of the pump, or we go to the suction side of the pump, we're now really pulling, right? And so if you were to open this valve up, you get no water when you have it set up to the suction side. It's gonna be a little dribble. So what he's saying is go ahead and open this up. This thing's been wide open. Start shutting it down until you got a nice stream here, and then you're good.
So it doesn't have to be
Okay.
wide open all the time?
It does not have to be wide open. And if you see this fall down, because that's your flow switch, well then you went too far, okay? So if you see you bring this up to a certain point and the flow switch drops down,
And the flow light
just
will go
open this.
off.
The flow light's gonna go off, drop it down just a little bit, okay?
You just want to get water coming out of there, even if it's just a
Doesn't
little
take-
bit.
it
You want to
only
have
takes
a
5
positive
gallons
pressure
of
in
water
there.
and running through that thing a minute, and it's like it's minimal, okay, for that thing to work. As long as your flow switch is up. Walk in a pump room and you don't see that green light, it's no different than you sitting at a red light. It ain't gonna feed a drop. That flow light has to be on in order for the system to work. Okay, so you walk in, if you don't see flow, time to investigate. Why don't I have flow? We either need a backwash, okay? Your inline filters. You guys have these on all your pools? Okay, necessity. This thing right here collects all your fine little debris, okay? You don't want all that debris passing by, especially sand particles and things like that. If you're in places like the desert, or you're at places where there's lots of sand, has metals in it. As those metals go past this and get into here, one, you can mess up your flow switch, but two, as those products tumble around in the bottom of the flow cell, believe it or not, they can create some stray voltage, okay? So it's really important to put these in. And so when you got no flow there, close the valves, open it up, okay? Has an arrow direction on it, you guys. So you're gonna plumb into here and come out of here. Open this valve, okay? Open this one, it's been closed because you pulled this off. Open this back up, close this one, all right? Close this one up, and you should see water just pouring out of here. Okay, well, so water pours out. We know we don't have a clog anywhere between that point. Now we put this on and we do the same thing up here, and make sure you can always pull this line off of here by just taking, you see how that thing moves? It's in there? If you take a little pliers and push up on it, you can pull the hose right out and see if you have any water coming out. If you don't have water coming out, you got a blockage somewhere after this into there, okay? So you wanna make sure you have that. Generally, you're gonna find if it's a cartridge filter or a DE filter, a lot of times this is either loaded up with a bunch of garbage or the filter needs to be cleaned, okay?
Are you gonna start stocking the strainers and the O-rings here anytime soon? I can never-
They're in the system,
Okay.
they're in their system so they can order. I mean, the good news for you guys is we're in Murrieta, so they get them the next day.
Here's all your parts.
Part numbers are on the back, so this is our large strainer, it comes with all the
No, I
part
came in
numbers.
just last week and they didn't know what it was.
Okay, so that's in our.
Show them the part number, that's in their system.
Here's where it drove me nuts as a commercial guy. I had to literally demand with my branches that I wanted them to stock X for me. It was to the point where I said, look, either you stock it or one of your competition is gonna stock it for me, because this is what I do. We're not the average pool boys being in commercial, that we have a pole in the back of our Toyota pickup truck and we're just running around brushing pools and dumping shit in. Okay, we are professionals at what we do. We need these things to be at our disposal. If I need a probe, I need it to be here. If I need that inline filter, that gasket that's in there, whatever, I need it. My pool will be down. The first thing that people do is they go to general managers of these hotels, or they go to directors and say, hey, I came and stayed at this hotel and I can't swim because you guys have the spa closed down, you know, and this was the reason I came here. And so they end up giving things away. And then they look at you and they're like, hey, how come it's down? You know, so if we have the parts available. Now, some of those types of parts, you need stock, so that you don't
No,
have to
we
wait
do,
for
we
that.
just order
Your
some.
O-rings, your
I don't know where
inline
you got it
filters,
from.
get some of that
You-
stuff that's inexpensive to stock and just keep it on your truck, and that's what I'm gonna get to as far as maintenance goes.
Did you ever have like little special boxes for each account, like you just leave on site, like this is like basing box or Marriott box, just, you know, for those?
But you can, I mean, you can, but I found that things just tend to get feet.
Yeah.
And you'll get people that think they're helping you out, and they're not helping you out, they're doing something they shouldn't be doing, so, I just made sure that every single one of my trucks had things on it that I knew I needed every day.
And expensive.
You know, well, in your trucks, you guys, like I said to you, if you standardize, and this is what's really important, is standardizing everything you do. Your injectors, if you're standardizing your injectors, you always have these on your truck, okay? You don't need 50 of them, you need a few of them on your truck. Rollichem squeeze tubes, Stenner squeeze tubes, those types of things, having those on your truck. Having a little bit of the 3/8 inch black tubing on your truck. These are all inexpensive things to have stocked on your truck. It saves you time driving across town. Unless you like traffic, you know, then don't do that. But these are things that are hard to get when you need them. So if you stock them, you have them at your disposal, or the shop has them at their disposal, whatever it should be. You've seen, you know, as much as I love all the commercial property, the commercial locations, SCPs, you know, PPs, Superiors, everybody, a lot of them don't stock these things. A lot of them don't stock these squeeze tubes, a lot of them don't stock this stuff, because they're looking at the stuff that goes off the shelf super fast. And so sometimes you have to take it upon yourself to go through that price list and just come down to the counter and say, hey, I need 5 of these, I need 4 of these, I need 8 of these, whatever it should be. But if you have these on your truck, you can fix it instantly. Okay?
When you get to distribution, you get to the counter and the guy doesn't know what you're talking about, you know, keep these part numbers. That still may not be enough. If they're searching under IPS, they're gonna get all the weld-on glue you could ever use. They're not gonna get our products. Our prefix that they search on is ISI. So when we came along, there was already an IPS. So ISI is our prefix. If you have, that's Pool Corp. That's the prefix to tell them to search for these part numbers. They should still be able to find them, but if they can't find them, tell them the prefix is ISI, and they'll find everything there.
All right, I know we're running out of time,
Yeah,
so
we're
we're gonna
gonna-
speed up a little bit.
Yeah.
So we're gonna go into ORP. Your ORP set point, like I said, is when you get this thing, the system set up and you've established that pH where it should be, and you know that you got a couple parts per million in the body of water, it's important, you guys, to get the body of water balanced before you start setting these controllers up. If you can take the time ahead of time to get them at 7.5, take the chlorine and get it 2 to 3 parts per million, it's gonna be that much faster for you to set this thing up. So get your ORP to where you see it reading whatever it's reading, and so say it's reading 690, and you got 2 parts per million, we want it to be 3, we set it at 700, right? And it's gonna feed until it gets to 700. Your dose time, once again, liquid, it's a 40,000 gallon pool, you need 40 ounces to get a part per million, but we know we don't need to put in 40 ounces one feed. So you break that down into how many things you think it could be, 3 cycles maybe? Say I want 3 cycles, so if it feeds 3 minutes or 4 minutes and it's off for 5, 3 minutes, 4 minutes, it's off for 5, so within 20 minutes, you're already back to your set point, okay? Now, if you see it's a heavy bather load thing and you need to run them longer, you run your feed time has to run longer, okay? You're running that ORP2 like we talked about, that's gonna be your saving grace, because as soon as it drops a part per million, ORP2 is gonna shoot it right back up. I mean, it's like, I never did any pools without it. After I started using it, it's the sweetest thing in the world. Overfeed timer, once again, this one's a little bit easier to figure out, because on your liquid chlorine, we talked about it takes an ounce for every 1,000 gallons. We can look at how many ounces we feed in 60 cycles. What would it take to get it to where you would be no more than 7 parts per million in an emergency, right? Like if something happened. So I always set my overfeed based up on how many ounces it feeds, what it would take to get there, and I say, okay, the maximum we could ever get to would be 6 or 7 parts per million, and that's where I land with my overfeed timer, okay? So that's an easy calculation for you with the liquid, because it's so easy to do. High alert and low alert, this is where a guy wants to get really, really tight in his things, and it's another safety feature. If we knew 700 was our 3 parts per million, you say, well, I don't ever want to see it more than 6. You could go to your high alert and say, okay, well, right there, if I'm looking at 3 parts per million at 700, if I put it at 730, it should never get over 730. That would be 6 parts per million. So it would shut off for you. So you can see there's multiple places here as far as safeties goes. You got your high alerts, your low alerts, you got your overfeed timers. You should never have a whole bucket of anything dumped in a pool if you use those correctly.
And that overtimer on the chlorine, if it goes into high alert, or I'm sorry, the high alert, not the overtimer. If it goes into high alert, it will stay in high alert until it drops below that number for 1 minute. So after 1 minute, it'll clear the alert, and you won't be in alert anymore. But it does stop feeding when it gets into high alert on the chlorine. It doesn't affect the pH.
It will reset themselves?
Yes.
The high alert and low alert on both pH and ORP will reset themselves. Overfeed timer, that's the flashing numbers, that by NSF certification rules has to be manually reset.
But see, the cool part of that high alert thing is like you just hit on, say it got to 730, it would shut off. But it would sit there, and if there was any kind of bather load whatsoever, pretty soon it gets below that 730 and it goes out of alarm. Okay, so that's the really cool part about that, is that using that is your biggest safety. So when you talk about liability as an owner, that was huge to me, and huge, okay?
And resetting an alert is just cycling through the mode button. So, when you get there, the alert's on, hit the mode button, cycle around, and that'll clear the alerts.
So there's your high alert. Your low alert and chlorine, I'll be honest with you, on mine, I never even messed with the low alert, because I wanted it to feed chlorine if it got down, even if it was at 500 or 600 or whatever, because I already knew that I had my overfeed timer set and I had my stuff in place that it was a safety, wasn't gonna go anywhere. So that you can bring up if you want to. I didn't, because I wanted to make sure it fed, okay? The ORP2, like we said, it'll only move within 10 millivolts. Here's the cool part. If you adjust ORP1 from 700 down to 680, okay? Watch this number, okay? So we have 690, right? I'm gonna go back around to ORP1. I'm gonna go to my set level. I'm gonna move that down to 680. I wanna go down to ORP2. You see what it did? It manually adjusts that 10 millivolts away. However, if you go up from that 700 to 710 to 720, you have to bring up the lower this ORP2 number to that 10 millivolts. So now I go back in, watch, ORP1, I take that back up to 700. You see where my ORP is still at 670. I have to hold that to bring it up, and it'll fix it, okay? So ORP2, your overfeed timers are gonna be based on your ORP1 on a lot of those features. Your high alert, your low alerts, all those are tied together with ORP1, okay? Temperature sensor, this was what comes with the 920. This is a nice thing to have. Right now it's 70 degrees in here. So the temp sensor is part of your saturation index, if you're doing saturation index and all that, okay? Any questions on the controller?
Real quick, on the temp sensor, it doesn't, if you leave it on that display, that display will never change unless you cycle back through. So if I was holding onto this, it would increase the temperature, but it wouldn't display. So don't look at it as a constant monitor if you're making changes. But the important thing about temp sensor and on this controller is if you have the remote monitoring capability, you can set your spa up, for example, to have a range of 98 to 103. If it goes outside that range, somebody hits the emergency shut off. If it goes outside that range, you can have it send you a text or email, or anybody on site. If you have an on-site facilities person, they can get an email or text. So you can know it way ahead of time that something's going on and you're not heating your spa, or you're overheating it. You can do it on a pool too, but you have the ability to set those high and low alerts on the different high and low alert on the temperature sensor, so that you can get notified.
Here's the other really cool part with the Wi-Fi. All of us are responsible for these pools, right? And so everything that we do in the pools is your fault, right? Your fault. My pool's green. This is it. Someone hits an emergency switch. This is a Saturday or Sunday, you're sitting at home having a beer, all right? That thing's green by Monday morning. Your fault. The great part is you get into these Wi-Fi setups, and now all of a sudden you get an alert saying there's no flow. Now you start talking to the director of engineering and saying, look, at 2 o'clock in the morning, this thing was, someone hit an emergency switch. This had no feed. I really need you guys to start taking ownership of this stuff. I'm not here every day doing this and that. And so what I started finding was my directors of engineering started buying into this program, okay? And so now he's on the night shift, and that thing's turned green, right? Now the general manager, the director of engineering are going, hey dude, what were you doing last night? Were you sleeping or what? Because this thing's been an alarm since this time, and the printout shows it, okay? I had a guy at a property, his name was Gustavo. Chuck's heard this guy's name for 1,000,000 years. This guy played with the controllers all the time. I just was like, I had it. We would have everything perfect at 1 o'clock. My guys worked from 4 to 1. We'd have everything perfect. We'd leave, next day, 10, 12 parts per million. We'd have pH through the roof, like crazy. I said, look, he's throwing sodium bicarb in, and he's just walking away. He's not doing stuff. So finally, we did 2 things in the controller, but finally, we did get the Wi-Fi. And I kept telling his boss, and she's like, no, he wouldn't do that. I just can't see him doing that. Finally, we had the printout and go, here you go. 3 days in a row, the exact same thing. Tell me Gustavo's not playing with it, okay? So I don't want to hear about it anymore unless you're going to do something about it. The other thing we did in the very beginning before we had Wi-Fi is, in behind here, you guys, there's a secret little button behind this 0 on the 920, or the 820s, either one. Behind here, you hold down that little button. Now, Gustavo can look at the readings, but Gustavo can't make any changes.
Oh, cool.
Okay, so I always call that the Gustavo button. You can turn that off, and you can make adjustments, okay? Everything works again. So you get your set levels, you go up or down. So that's a nice little feature too. If you got a guy that's playing with things, you can lock them out.
Line or load side on the connections?
The what?
Line or load, when you connect your controllers, do you want it on the line side or load side?
What do you, I mean,
On the electrical feed, do you want
are
it?
you hardwiring?
Yes. Or-
So if you're hardwiring, you're pulling this out.
Right.
And you're going right into the,
It doesn't matter whether it's online or load, you want it to turn on with your pump or with the time clock or the automation?
well, if you want it to turn on with your pump, that's a great thing to do, but we have another way you don't have to do that, and that's using this.
But you want
Okay.
this thing to have constant power, or does it matter if it turns off every day?
Well,
It doesn't
shouldn't
hurt
turn
the
off if you're
controller or the
commercial.
settings to shut off. If you're on monitoring, you really want to know what is happening
Right.
24 hours, and most of commercial will certainly run 24.
You're talking more for residential, right?
Right.
Yeah, yeah.
So
So
if
if
it does
you're
shut
doing-
off, for example.
It's no
it's
problem,
not-
it's not gonna hurt anything to shut off and
If
turn
you're
back
gonna do
on.
residential, my recommendation to you is to buy that guy,
Gotcha.
okay?
Yeah.
It's gonna have your pumps built right into it, turn it on, turn it off, whatever you wanna do.
And it's got Wi-Fi.
And it's got Wi-Fi. You'll do exactly the same thing as that, except it's got the pumps built into it. It can't be used in commercial. The pumps are not NSF rated, so that's why it can't be put in, okay?
Is the Wi-Fi, the monitoring platform for that model look just like all the others?
Identical,
Same, yeah.
identical. You can do all your changes, you can do everything, just like you would on the commercial.
And we have Wi-Fi, and we also have a non-Wi-Fi or Ethernet hardwired version. If someone has Cat5 cable in their pump room, they can go with the hardwired version if they want. Or they can do Wi-Fi, doesn't matter, but if they have that capability, they can run on a hardwired Ethernet.
You can do cellular, you can do Wi-Fi,
Yeah.
you can do Ethernet. I mean, Ethernet, you don't have to worry about anything falling off, so if it has the ability to do an Ethernet, it's awesome, because you never have to worry about things dropping out. These items right here, this item right here, when I owned my commercial pools, had I had these out, when I had my commercial pools, there wasn't a pool I would have put in, not have one of these put in with it. For the few $100s that this is, you as an owner, this is your insurance policy. The controller now plugs into here. This gets plugged into the wall, and the line that's feeding your flow cell, okay, gets a T put in and comes up onto this side. Now what does that do? The cool part is if the pump fails, okay, for any reason whatsoever, there's no pressure from the pump on the head side, it's going to take this and say, hey, I've got no flow, it's gonna shut off the controller, so that's gonna black the controller completely out, okay? A lot of guys will wire them in, okay? They hardwire them in to where the pump is gonna, when the pump shuts off, it shuts off. However, if the pump fails, okay, the motor locks up, there's still power to the motor, which will still keep power to the controller, and you can still overfeed chemicals. This is the ultimate safety. The Utah, it is now mandatory in Utah, every single commercial swimming pool has to have one on it, okay? And you're finding lots of other states that are starting to do it. East Coast and Florida and places, Texas, they're requiring it because they don't want the safety issue that's involved with it.
And this is,
Pressure switch, or is
yeah,
it?
this is a secondary protection, and that's really the insurance part of it. We do have the primary protection, which is our flow cell that's built into the cell. That's required.
Flow switch.
Have to have the flow switch, sorry. Yeah, built into the cell here, so that's your primary. So if that pump fails and the flow goes away, that should trigger. The secondary says, okay, if that fails in that scenario, we have the ultimate shut off, which is the pressure switch.
And they're not connected together in any way, they work independently,
Correct,
right?
correct, yeah.
It's on the back. It's in here.
PS 100 is the part number.
PS 100. It's on there.
Hey, Ted, on the sensors, does high sine earth affect them in any way?
Yes, oh, absolutely. High sine Eric, low sine Eric, I mean, it's going to be,
One stay below 50 or 30 or what do you?
if you run your sine Eric, I myself, 30 is like great spot, okay? 22 in cyanuric acid gives you 80% of the effectiveness of cyanuric. So you can see from 22% to 80 or to 100 is very minimal amount. So if you stick it at 30 and you get backwash and stuff and it drops a little bit, you bring it back to 30, you'll be rock solid all the time.
But the sensors are affected by it.
Very much so, because when you're, again, it's a TDS, okay, it is acidic. So you're going to be dropping your ORP. So if you guys, make sure that when you guys do cyanuric acid, okay, this is really important, is don't go crazy either, because it's like cyanuric acid is not like you gotta put 20 pounds in today. If you put in 3 pounds and you do it over the next 7 days, you're good, okay? It doesn't have to be like this national emergency to get it in there. But if you're the type of person that wants to put in there 8-10 pounds, you gotta know that that ORP is going to drop, okay? Your pH is gonna drop and your ORP is gonna drop, and it's going to start overfeeding on your product, okay? So if you know that you're going to put in 6 pounds of cyanuric acid, go to your ORP and drop it 10 millivolts, because you're already at 3 parts per million, right? If for some reason the cyanuric drops the ORP, you're not gonna overfeed, okay? It's really, really a big thing you wanna watch with cyanuric acid.
Second question, on the controller, if you're in a situation that doesn't have Wi-Fi, is that the cellular portion of that? Or?
Yeah, you can do cellular.
You do a cellular hotspot.
It's a hotspot.
We don't have a cellular controller. You do a cellular hotspot. The best
Right.
part about that is you do one hotspot, you can run 10 controllers in an equipment room if you need to. If you do cellular controllers, there are some out there that are cellular based, that you're paying whatever the monthly cell fee is on each controller. So if you just do a hotspot, then you can control all of your controllers on that one hotspot.
Verizon sells these little things, they're called MiFis or hotspots. They're about this big. You can put that in a pump room, and you only need 1 gig. Okay, so you're paying like $20 for it.
you need a low number because this basically is like a cell phone when it calls out. Okay, so it's gonna open and blip and and the next time it calls out, it's gonna open up again and bring the information back. So you don't need a one that's got a big gig in it. It's your lowest you could possibly buy. Okay, so if you use one of those, they work great. I did controllers up at Yosemite Lodge. I put in 13 controllers and that's what we did. There was no way of getting Wi-Fi, there was no way, you put in the cellular, because they did have a tower that they could get cellular, put those in and they worked fantastic, okay? And again, like he said, if you have a pump room that's got 5 controllers, you can run all 5 of those controllers, you know?
I'd
That's
say the
great.
connection on this too is easier to get than most other devices we're used to dealing with trying to connect. We have some pretty, weird pump rooms that are pretty far and they stay connected pretty well.
Okay.
So Dustin, you guys do a lot of commercial, do you guys find you need a hotspot, or?
I only have a handful of controllers that we have connection issues, and I probably have 50, 60, 70 of these online right now, and even in very remote pump rooms that, as long as, especially on a resort, you've got a Wi-Fi system that, everybody's using, so there's some type of connection. But yeah, if you've got a weird one out in the middle of Campo or whatever, you gotta get that. But those are cheap, and you sell that and make them pay.
Well,
for
the other
that
thing you
as
can
part
do
of
too
your
is
service.
remember this, if the customer has Wi-Fi, just because you can't get the signal there, is they can also buy an extender, you can buy it looks like an antenna almost, it sends a signal. You'll end up putting a box in the pump room and a lot of times you can get it that way too, okay? All right, so let's get into the standard maintenance stuff. This is key because Chuck and I and Danny get these phone calls all the time. Like I said to you earlier, we'll get guys call up and go, hey man, I put this thing in the beginning, unreal, love it. I just love the machine, but it's not working anymore. Well, hold on. What's not working? If it worked in the beginning, why isn't it working now? Okay, so let's do a few things. Tell me what your run times are. I'm gonna go all through that with you. I'm gonna say, okay, well that all looks good. That sounds good. When was the last time you changed a squeeze tube? It's one of our biggest ones, Chuck.
Oh, by far.
By far, one of our biggest things we get is squeeze tubes, okay? These squeeze tubes, you gotta remember that little wheel that's going around. I don't care if it's the Rollicam or it's the standard. That thing's going, if you measured the mileage, it'd be like you driving to New York, like in no time, okay? That little tire that's in there is just wore out. Throw a new squeeze tube in there, still have a problem, okay? It's still not feeding, okay? Injectors, okay? If you're not using injectors, I strongly recommend that you do it for 2 reasons. One, we take our tubing, and a lot of times with Stenner, it comes without the injector, okay? It comes with one that looks like an injector, but it doesn't have a check valve in it.
You mean the check valve?
Check valve,
versus
yeah.
the
These are
standard?
check valves.
Got it.
If you don't use those, remember we're diluting our acid 4-to-1. We got high pressure in our line running through. What happens is that it seeps water up into our 4-to-1, and now you only have 15-second feed time, 15 seconds barely clearing that tube, and so you have diluted acid. You don't have true acid. And so you get those variations where it's feeding. If it's continually feeding, it keeps it clear, but if it's not, you dilute. Okay, so that's a good reason to have this. That's one. Same thing with chlorine. We don't want to dilute our chlorine, we want 12.5%. We want it to be that heavy dose. Now, these are beautiful, these new ones, okay? Rollicam already has them, okay? It comes in their box. It's a check valve. The only bad part about the Rollicam one that I like about this one is that with the Rollicam, there's no way to take that thing apart, okay? You can stick a screwdriver in there and clear the ball and try to get it clean or soak it in some acid and that type of stuff. This check valve that Stenner came out with has a special ball in it, which I just lost. It's right at your feet. Okay. This has a special, like a ceramic type of ball in it. It has a spring in it that's very expensive. It's a spring that is for chemical. Okay. The nice part about this is that that's all you're fixing.
So
You pull
that's
that
new
apart.
to the
This is
duckbill
the
deal?
newest one. They get rid of the duckbills. I will not use a duckbill ever again. Now that that's out. The other beautiful part about this is, and you probably don't know this, but it's in standard information, is that it takes 19 PSI to pop open that duckbill. Okay? Now that doesn't sound like a lot, but that's back pressure on our squeeze tube, right? So that's that much more pressure that the squeeze tube has to work. This opens at 5 PSI. So it's really smooth. It just opens and closes. It does a great job. These were not out when I owned my commercial company, or I would have had every single one of my properties with these on. Now, that being said, what's nice about it is you see how you can clean it, right? That's, you just pull that thing apart. On any of the other type, like if you're using the Rollicams, every single 3 to 4 weeks, okay, if you know this is a heavy use property or you're pumping a lot of product and stuff, especially in hot water, take off where it threads onto there, or on a Rollicam it's barbed, it's a barb fitting, the tube, clear tube pushes onto it. I always leave about a foot, if not a little bit bigger, coil on the ground where it goes in. I cut off, and you always want to cut it on the back side away from your face because they're under pressure, it'll shoot up in your face. Wear safety glasses, but do a really small slice on it, let it relieve pressure, pull it off, slice up the side, switch the acid for the chlorine. If you switch the acid for the chlorine, the acid cleans all the garbage that gets in the chlorine.
Let me jump in real quick. A
Salt.
lot of you guys are using the brass fitting on the Rollicam. So if you're using the brass fitting, they do have a barb to barb check valve in the box. So they give you the brass fitting and then 2 check valves. One has a thread on the end. That's the one we like. We like the threaded one that you tap a hole and you thread it in there. 1/4 inch NPT tap, thread that in there. Then you can do what he's saying. You can swap those lines over. If you're using the larger, brass fitting and you use the inline check valve, you can't really do what he's describing unless you put the check valve down real close, and then you'd be swapping it off of that check valve. So,
Yeah.
so
But
know
you
what
can
you're.
also put an insert in the pipe for the 1/2 inch fitting that goes to 1/4 inch national pipe thread, and you can actually put in a regular check valve.
Yeah,
Okay, but
we're
these,
using
if you
the brass
notice,
for
the
chlorine
beauty of
and
these
then
is that you
the
can use
feathers
1/4
for
inch,
But you use the
or if you had
inject
the
check
1/2 inch
valve at the
thread in
end.
there,
Yeah.
you can thread these in a 1/2
Yeah,
inch
so
too.
we still have to do
Okay,
that.
so that's what's really
On the
nice.
note too of the swapping of them, just from somebody who is, please be careful with this. Remember, you're mixing acid and chlorine on a very small basis, but hold your breath, or at least you have to brace for impact on things like this. I've seen so many guys come in and pull an injector with no glasses on and don't realize how much pressure's right there.
Yeah.
Okay, but if you're doing it every 3 weeks or 4 weeks,
I get it.
you aren't gonna have as much pressure because you aren't gonna get as much garbage buildup in there, because it's
I
still
wish it-
seeping
I always
through.
hook up and they react.
It's still seeping through. The problem is that when they get loaded and you got all that back pressure, yeah, that's difficult there where you have it. Now, in those situations where you know they're super clogged,
I cut them.
pull your squeeze tube out of the pump. If you
Yeah.
pull the squeeze tube off, it relieves all the pressure. And then you can do it really, really easy.
Yeah.
I just think this is the area where most people are injured. I've had the most amount of
100%.
injuries in this specific.
Every single one of my guys had safety glasses.
Well, they have them.
Well,
I'm just saying, man, you had 26 guys, I've got 14. If I walk into a pump room, someone's wearing sunglasses or safety glasses, it's my best day ever. It
But you know
rarely
what?
happens.
You buy cool looking safety glasses.
I've tried,
They can be
man.
sunglasses
Oh,
or
I'm
safety
ready.
glasses. They can be, those are a lot better than the ugly looking white ones, the clear ones. All right, next thing, if you're using Stenner and you're not using one of these guys, you don't know if your injector's clogged or not. This little guy has threaded pieces that go in here, top and bottom. Your tubing goes into here, your tubing comes out. You mount this, when the pump is running, this little ball is going up and down and up and down and up and down. And if you get there and that little ball's not going up and down, clog, time to switch.
That's on the.
If you don't have these in yours and your Stenners, dude, like I said, time is money. You don't wanna sit here and try to figure out your work, and it's like, the cool part with Rollicam that I love about it is it's really an idiot-proof, pump, because you can see the product being picked up out of the barrel, through the clear tubing, if you see the line in jerking, injector's clogged. So it's that part about Rollicam I love about it. But now Stenner's gone to the big boy side, which is even cooler, is that Stenner now has a pump that's a 150 gallon a day pump. They have a 300 gallon a day pump. These things, when you get these big 1,000,000 gallon pools, they're the bad boys of the town. They're gonna get the product in and it's gonna get fast, okay?
Yeah,
So-
that's one of the things people are confused about. Our systems, or anybody's control system, the only water it cares about is the water that's in here. So the controller itself only knows this water. If it's a 1,000,000 gallon body of water out there, it still only knows this little bit of water here. What does change is your output device, your pump size. You get into larger pumps, like he's talking about, 300 gallon a day pumps, when you get into those really massive bodies of water. We have a controller on test tank. It's a wooden barrel. It's 1 million gallons down in Texas at the University of Texas. And we've got one of our controllers on there, but they've got 320 gallon a day pumps, one for the acid and ORP1 and ORP2 on the chlorine.
Well, that's the funny part, is that's one of the questions we get all the time at the pool shows, right? We're at a show and a guy comes in and goes, well, how big a pool will that run? How the hell big do you want it to be? It's the pump that pumps the chemical that is gonna tell you that. I mean, that has nothing to do with the controller, doesn't know whether it's 2 million gallons or it's 50 gallons. We're going to set it up based on the pump size. So this is where we really can help you guys out. And I stress that so much because we are so different than every other controller company there is out there. We love the personal touch that we talk with you guys. We want you to be a partner with us, not a number with us, okay? And so when you call and you got these questions, there's never a dumb question that you will call us with. We will walk you through what size I recommend the pump should be. Let's start out with this. I'm gonna walk you through setups. I'm gonna help you out because the more successful you are, the more successful you make him, the more he buys. I mean, that's just the bottom line. I'm not here to sell controllers. I'm here today with this whole class, as well as Chuck, is to teach you preventative maintenance, teach you proper setup, teach you all these different things. Whether you use my controller or somebody else's controllers, these are all things that you need to focus on is you know, the commercial stuff especially, is your proper setup, your maintenance. Your maintenance is the biggest part of this thing. Is when you set it up in the very beginning, we get this all working perfect, there's nothing to change. That's the way I always laugh when someone calls and says, hey, it worked perfect the first 3 months, but no, it doesn't. Well, what's changed? Okay, that's the only thing that changes.
Vita good for how big of a pool? Vita in the backyard, how many gallons?
Oh, it'll do 40, 50,000 gallons.
40, 50?
I have
50?
I have one on my house and I have one on an Airbnb, and let me tell you, they rock.
It's 22 gallon a day pumps. Those are Stenner pumps on the front of that.
Those little ones?
You're talking about the residential product, the Vita Pure? It's 22, it's two 22 gallon a day pumps mounted on the front. And so it'll handle, easily handle a 40,000 gallon pool.
I put it on a 52,000 gallon pool. They had a block party at this property. So for 2 days, Saturday, Sunday, they were having these block parties with the jumpies and all this different shit. And there was 1 million kids. All I did is took the controller over there. I didn't even take all the other controller off. All I did is took the lines and plugged it into the flow cell, and took the lines off my regular commercial unit and put it into that. All weekend, we watched it. It stayed solid the entire weekend with mass beta load. So yes, it'll do big stuff.
Just to follow on what Ted said about, you know, we're trying to, and especially with this class, we're trying to help you guys maintain these down the road so that you know, you get the best performance out of the product, whether it's ours or someone else's. You know, when somebody calls me with a problem, I can tell within 30 seconds whether it's the controller or it's not. So when it's not the controller, then it's the feed pumps typically, or it's the injection points. So we spend as much time talking about stuff that's not our product on the phone with you as we'll spend talking about the controller, because it's electronic, it's a computer, it's pretty easy to figure out what's going on there. It's the other part of the installation that we spend a lot of time helping with on the phone. So
When you guys set these up, I know it sounds like a nightmare, like setting up your pH, but it goes really fast, you guys. It's like if you get the run times in there, here's the other thing you can look at and say, well, okay, I put in 180 seconds, okay? But stay there to find out, is that 180 seconds going to do what it needs to do? If it brings it to 7.3, right, instead of being at the 7.5 because you surpassed it, well, what do? We go down to 120 seconds, or instead of that 7-minute delay, we might go to a little bit longer delay, whatever it should be. But take the little bit of time that it takes to get your pH stable. And then with your liquid, like I was saying, is if you have the runtime set up on the liquid fast, okay, when you're doing it, and the thing's running with the amount of ounces we were talking about, so it's 1 ounce for every 1,000 gallons to 1 part per million, well, within 15 minutes, it should have satisfied itself if you had that runtime set up good. If it didn't, and you have to sit there for 45 minutes, it's way too long for when that bather load gets heavy, okay? So if you take a little bit extra time in your setups, instead of guessing, use a little more science behind it as far as the ounces that need to go in. And that's the biggest part, is I push so hard on having the proper pump size for the chemical and knowing how many ounces of product that pump is capable of to get you to your set point fast. That's the ticket, okay? Anybody have any questions on anything?
Adding chemical, should we close flow on the controller?
Adding what kind of chemical?
Like if we're adding like 20 pounds of bicarb?
If you're adding 20 pounds of sodium bicarbonate, my recommendation is you close both of those valves. Let the bicarb stir it up with the, whether you're using a brush or you're using a net, moving the water a little bit, getting it and saturating the pool really good. But you can still, at that point, you can still have it where it's gonna make some changes and you're gonna need to make an adjustment.
Lube or no lube on the center pump tubing?
I never did, to be honest with you. You can. I just never did.
I
On
would
the
say standard
Rollichem-
no, Rollichem, yes.
On the Rollichem you do. Yeah. Yeah. So yeah, you just have to look at the fact that those squeeze tubes stretch, you guys. They stretch and they wear out, and it doesn't push the volume anymore. That tolerance is super tight that's in there. And as that thing gets squashed, and you've pulled out stenters, you guys, and they're flat as a pancake. You go, how the hell is anything going through there? Nothing is. Okay? So that's why, again, that I like the big stenter, the big pump, because even when it's half wear out on that stenter, I'm still getting 3.5, 4 ounces of product. In its worst scenario.
And if we have a flow indicator, then we'll know that we're getting
Exactly.
That's right.
Exactly.
Oh, random question. An account we took over, and it's not one of mine, but I happened to go there to check something for somebody else. The bulb is all white, brown or whatever. New one, or can you disassemble them and
This
clean
one?
them? Yeah.
You might be able to acid wash it a
You
little
can
bit.
try.
It's
That's what I
not-
thought, it was
but-
more
but
than
it-
that time than it's
So,
worth.
yeah, externally, it's
So I
going
was
to
thinking, how am I gonna get in there?
Yeah,
Get all the
externally,
nooks and
externally
crannies?
it's gonna age, and you're gonna see some, outside you're gonna see some discoloration.
Yeah, yeah.
But yeah, you can take it apart, take the
So
valves
just-
out, it's probably not worth
Faster
it.
to just get them back.
Yeah.
When you get a new one, you're gonna get new ball valves, you're gonna get, just
Yeah.
save the old parts off the old one, but you're gonna
That's what I
get
was
a new
thinking,
flow
like
switch.
screwing all those
You're gonna get all that
things and
stuff new.
conference
Let me
tape,
eliminate
put
one
them
of the,
all back
let me eliminate one of the
on.
phone calls I get all the time. So when you guys take out a sensor, don't take this nut all the way off, because there are a bunch of parts in there that make it not leak.
No, I just.
And so when you pull, when you take that whole thing off and the O-ring hits the floor and then bounces into the grate on the floor, you're not gonna be happy, because we don't
It'll
sell
leak.
that O-ring. Now, it's probably, the size is available somewhere, but all you need to do is loosen it and it'll slide right out.
Max them out, doesn't matter where they're at inside the
Yes,
flush
that's
valve?
what I'm
Yeah.
getting to next.
Good point.
I'm glad you said that. Okay, so when you put your probes in, this is what I see a lot in the field, right there.
All the way down. You
Buried
don't
to
want
the
it all the way
bottom.
down. Yeah.
Okay? That probe's not bathing, okay? Remember where we said junk collects in the bottom, okay? You wanna bring this probe up about halfway, okay? You want it to get that nice clean water going across it. It's because that water is in there, it's creating a venturi. It's coming up over that flow switch, it's dropping down, and you'll see it. You can see those things kind of puff up a little bit. It moves the water around. You want it to be in that middle section for it to work the best. You won't get air bubbles, especially if you have a pump that's got an air leak, and the air leak, it doesn't collect the bubbles as bad, as it surpasses the bubbles by, okay? Is there anything I didn't hit on, you guys, that you wanna know?
We just posted on our website, so if you haven't been to our website, it's on the internet. The internet's not going away. We think it's here for long term. IPScontrollers.com, jump on there. Halfway down, about on the front page, there's a video that's been there a long time on installation. So it just gives you kind of an idea, a generic idea. It's real simple, it's animated, and it'll show you what an installation looks like. We just posted a programming video, like last week, and it takes you all through all those buttons that Ted just talked about, talks about overtime settings. Not in the detail we give you, but it gives you at least an idea. So if you have new guys that have never worked on these, just run through it. It's 13 minutes of your life that you won't get back, but it's good education, so.
Well, the good part,
Wi-Fi
you guys,
Wi-Fi platform is on your website too? Or
What?
the Wi-Fi platform, or where you access the Wi-Fi on the?
It's a
controller?
different website, it's a monitoring website,
Okay.
but it
so when
is,
you wanna do the website, just when you get the instruction manual, just start out at page 28. It's gonna give you the first steps.
that's all the Wi-Fi part of it.
You guys, the reason that you see this controller, it really is super user-friendly controller. Like I was saying to you, after you've established your ORP runtimes and all the different stuff, the only button you're ever gonna do is gonna go to your set level up and down on ORP. If you get all your runtimes just right, so you're never messing with any other buttons. If you've used anybody else's controllers and telecoms or any of that, you know how much of a pain it is. You're going from a different page to a different page and all this other stuff. We specifically designed this to make it so user-friendly, to make it fast. I tell people all the time, I don't care what controller you're using, I can go in here and adjust 5 controllers before you finish one of those. Okay, and time is money, and that's what it comes down to.
This is not off the wall. Back when Carl was still here, I think he talked to you on the phone, somebody in one of the rooms I went behind had evidently, or maybe I'm wrong if I remember it right, pushed the buttons too many times and it went into some mode that you had to walk us through to take it back out of it. They went through those sequence so many times, it went into something else.
Shouldn't be, you should be
Reset or
able to
something?
push the buttons as much as
Okay,
you want.
maybe I heard
Yeah.
it wrong.
Yeah, now, if you have a really old controller, the buttons can wear out. I mean, that's certainly, but I mean. you
I
get-
thought he said.
Yeah, there's
whatever it
nothing that
was,
you can
it-
push.
It went through sequences so many
No.
times and it went into something.
No, that shouldn't.
You had to walk them through it.
No, I wouldn't, no, I don't know of anything like that would do
Reset or
that.
something, okay, maybe I
Yeah,
heard it.
and just, so you know, when you guys are doing the programming, you don't have to wait. When you push and change the value, you don't have to wait, you don't have to hit enter, you just go to the next thing and it saves what you just did,
You
so.
get lost on the competitor's controller, you push the wrong button and everything's gone. And
Yeah,
it's
no,
just-
it's-
Then you get these back doors and
That
you're just
thing's a
like,
nightmare, dude.
it's gnarly.
It's a
I mean,
nightmare.
the only way to learn it is to have it, sit there and push the
Well, why do
button
you
for
have to do
hours
all
and
that?
hours.
Why do you have to do it?
Because of the, I don't
That's
know.
because the way they designed it. I mean, I'm sorry, but, you know, if every single time you jumped in your truck and you had to go to a console and you had to go through all these steps to start the truck, you'd be buying somebody else's truck. I mean, it's just, like I said, time is money, and you shouldn't have to be that confusing. I mean, it should be, to make a set adjustment should be just like that. It just should just be right in front of your face, push a button, boom, done. Not have to go from, you know, anything that's gonna have where you have to page to the next page, and you have to do this, you do that. I mean, I was talking to a guy the other day with Intellicam, and I told Chuck about it, and it was like, I told this guy, are you serious? I mean, like, he says, I'm pulling my hair out.
It happens.
Yeah, so, yeah, I mean, that's the whole thing is when, because I own a commercial pool company, having the ease was just so easy to train new people on these controllers.
Our competitors are, their products are our best sales force, so.
Yeah, that's the truth. You guys know that we're a 5-year warranty on all electronics, okay, and the whole electrical part of it. 1 year on the probes. You can get longer longevity out of those probes. I mean, I've had some pH probes out in the field that are 4 years old, if you take care of them right. That's closing those valves and doing that type of stuff. But whenever you guys have any issues, you don't deal with Superior, you're not gonna deal with any of the commercial people. You're gonna deal directly with us, okay, like warranty issues, any of that type of stuff, you guys call us up. But you guys have the phone numbers, whether it be Chuck, Danny, or myself. We are the only people that pick up the phone. We will never be like some of our competition where you talk to customer service. We will talk to the owners of the company. When you're gonna get an answer, you're gonna get a walkthrough, exactly what's going on. And if it doesn't, we can't resolve it, we will fix it, okay? So that's the good part.